Long before satellites, modern navigation, or even reliable maps of the known world, someone drew a coastline that seems to hint at lands now lost beneath the sea. Was it imagination, a distorted memory, or evidence of a forgotten world once known to ancient travellers? The answer may be hiding in the lines of a map that should not seem this mysterious. If you enjoy uncovering lost civilizations, ancient mysteries, and forgotten chapters of human history like this video, subscribe to the channel and join us as we follow the ancient map that points to a lost world. The parchment is old enough to look fragile even through glass, its surface browned by centuries, its lines crowded with coastlines, place names, islands, compass roses, and the tightly packed confidence of a world trying to draw itself. At first glance, it seems like many surviving maps from the Age of Sail, imperfect, beautiful, half practical and half inherited. But one part of it refuses to remain ordinary. Along the lower edge, beneath the familiar contours of Africa, and across the southern reaches of the Atlantic, a strange coastline stretches into territory that should have been uncertain, misunderstood, or completely unknown to the people who copied it. Its shape is distorted. Its orientation is difficult to reconcile with modern geography. Yet to generations of readers, researchers, enthusiasts, and skeptics, it has carried an irresistible suggestion. Perhaps this map preserves something older than the age that produced it, something copied from sources now lost, something that appears to point toward a world erased from ordinary memory. The map at the centre of this mystery is usually associated with the Ottoman admiral and cartographer Piri Reis, who compiled his famous world map in 1513. Only a fragment survives. That fragment is enough to show portions of Western Europe, Western Africa, the Atlantic Islands, and the eastern coast of South America. It is also enough to create one of the most persistent mysteries in the history of cartography. The map itself is not hidden in some forgotten ruin or sealed chamber. It survives because someone preserved it. Yet the knowledge behind it is harder to trace. Piri Reis explains that he worked from older charts and geographical sources, combining information from different traditions. Some of those sources may have been relatively recent. Others may have descended from older Mediterranean mapping practices. Exactly how much older knowledge flowed into his work remains uncertain because the documents he used have largely vanished. That disappearance matters. Maps are unusually fragile forms of knowledge. They travel aboard ships. They are unfolded in wind, handled with wet hands stained by salt, copied, corrected, torn, burned and discarded when newer versions arrive. A single chart can contain observations gathered across decades, perhaps generations, without preserving the names of all the sailors who contributed to it. The map that survives may therefore be younger than some of the information within it. This does not automatically make the information mysterious. It simply means that cartography can accumulate memory in ways that are difficult to reconstruct centuries later. What survives in the record suggests that early modern map makers often worked with layers of inherited material, rather than creating their world images entirely from first-hand observation. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. The world of 1513 is changing rapidly. European ships have crossed the Atlantic repeatedly. Portuguese navigators have pushed around the coast of Africa and into the Indian Ocean. Spanish expeditions are transforming European understanding of the lands west of the Atlantic. Coastal knowledge is expanding faster than the ability of scholars to organize it. Geography is no longer only a matter of classical texts copied in libraries. It is becoming an unstable mixture of ancient authority sailor experience, political secrecy, rumor, measurement, and discovery. Maps are strategic objects. Kingdoms guard them. Captains correct them. Merchants depend on them. A coastline drawn slightly better than a rival's can mean the difference between reaching a harbour and wrecking a ship. In this atmosphere, Piri Reis produces a map that appears both modern and deeply traditional. Some coastlines show knowledge associated with recent Atlantic exploration. Others seem shaped by older cartographic habits. This mixture later becomes central to the mystery. If one part of the map looks surprisingly accurate while another appears strangely stretched or rotated, it becomes tempting to imagine that multiple eras of geographical knowledge have been stitched together. That temptation grows stronger because Piri Reis himself indicates that he consulted numerous earlier sources. Scholars still debate the precise identity of some of those sources, and the evidence remains incomplete. The most controversial interpretation arrives much later. Some 20th century writers argue that the southern portion of the surviving map represents Antarctica, perhaps even Antarctica, before it was covered by its modern ice sheet. If true, the implication would be extraordinary. It would suggest that accurate knowledge of a southern continent existed thousands of years earlier than conventional history allows, possibly inherited from an unknown seafaring civilization. The idea has become deeply embedded in popular mystery literature. It is dramatic, elegant, and emotionally powerful because it seems to turn a damaged Renaissance map into a message from a forgotten world. But the map does not provide such an easy answer. Mainstream historians of cartography generally do not accept the Antarctic interpretation. There are strong reasons for caution. The southern landform may instead represent a distorted extension of South America, a consequence of projection problems, copying errors, uncertain measurements, or the tendency of mapmakers to fill unknown regions with expected land. Early maps often bend familiar geography into unfamiliar shapes. Latitude can be approximate. Longitude is far more difficult. Coastlines gathered from separate voyages may be joined incorrectly. A continent that appears astonishing when compared loosely with a modern map can look much less remarkable once the techniques and limitations of 16th century cartography are considered. Yet dismissing the Antarctic claim does not make the map uninteresting. In some ways, the more ordinary explanation is more revealing. It leads into a much larger problem: how much geographical knowledge has vanished simply because the documents that carried it disappeared. Ancient Mediterranean sailors explored coastlines for thousands of years before Piri Reis. Phoenicians, Greeks, Romans, Arabs, Iberians, Italians, and countless unnamed mariners move through networks of trade and navigation. Their surviving maps represent only a tiny fraction of what once existed. Coastal knowledge may have been copied repeatedly, altered repeatedly, and preserved indirectly in charts whose original sources were already forgotten. There is also another lost world hidden behind the map, one that does not require Antarctica at all. The coastlines known to early humans were not always the coastlines seen today. During the last ice age, enormous volumes of water were locked in continental ice sheets. Sea levels were far lower. Vast plains stretched across regions that are now underwater. Britain was connected to continental Europe. Southeast Asia contained larger expanses of exposed land. The Persian Gulf was partly dry. Shelves now submerged beneath dozens of meters of seawater were once landscapes crossed by animals and human communities. As the planet warmed, those environments disappeared beneath rising seas. This creates a strange convergence between cartographic mystery and geological reality. The Piri Reis map probably does not preserve a precise Ice Age chart. There is no accepted evidence that it does. But humanity genuinely has lost entire inhabited landscapes. The existence of drowned worlds is not speculation. Archaeology and geology continue to reveal them. Ancient coastlines have moved dramatically. Settlements may lie beyond modern shores. Rivers once flowed across land now covered by ocean. The real mystery is therefore not whether some impossible civilization mapped Antarctica before history began. It is how much ordinary human history disappeared when the landscapes themselves vanished. The old parchment becomes more interesting when viewed from that angle. It sits at the meeting point between two kinds of absence. One is documentary maps copied from map sources' lost knowledge inherited without complete explanation. The other is physical coastlines, drowned plains, submerged entire environments erased from sight. Somewhere between them lies the powerful idea of a lost world, not necessarily a technologically advanced civilization hidden from history, but a past geography so different from the present that even familiar continents once had unfamiliar shapes. And that is where the map begins to change. It stops being merely an object accused of showing the impossible. It becomes evidence of how uncertain geographical memory can be. The lines on its surface are not a photograph of the ancient Earth. They are traces of voyages, assumptions, measurements, inherited traditions, and missing documents. To understand why one strange coastline became famous, the story has to move backward through these layers toward the man who assembled them and the older sources that may have reached his hands. Piri Reis does not begin as a scholar sitting quietly over manuscripts. He comes from the sea, born sometime around the late 15th century in the Ottoman world. Probably in Gallipoli, he grows up at the edge of one of the most active maritime zones on Earth. The eastern Mediterranean is crowded with merchants, privateers, naval patrols, pilgrims, fishermen envoys, and rival fleets. Venetian galleys cross paths with Ottoman vessels. Islands change hands. Ports become military targets. Information moves with cargo. A sailor can learn more about coastlines in a single season than a court official might learn in a lifetime, but that knowledge is scattered, practical, and often secret. It is in this environment that Piri Reis begins to collect the raw material that will later become one of the most discussed maps in history. He is connected to the famous Ottoman corsair and naval commander Kemal Reis, a relative under whom he serves during campaigns across the Mediterranean. The distinction between corsair naval officer and state-sponsored raider is not always clear in this period. Sea warfare operates in a world where private profit and imperial policy overlap. Ships are captured, crews are interrogated, cargoes are seized. Charts, logbooks, navigation instruments, and written notes can become prizes as valuable as silver. For a man interested in geography, warfare provides an accidental library. Each captured vessel may contain another fragment of the known world. This matters because the early 16th century is an extraordinary moment in the history of maps. Europe and the Mediterranean are being flooded with new geographic information, but that information is uneven. Columbus reaches the Caribbean in 1492. Portuguese sailors are already pushing south along Africa and around the Cape of Good Hope. Vasco da Gama reaches India by sea in 1498. Cabral reaches the Brazilian coast in 1500. Other voyages follow rapidly. Coastlines that had been theoretical or unknown to Mediterranean mapmakers are suddenly being measured, described, and drawn. Yet there is no single global database. Discoveries move through royal courts, commercial networks, espionage, rumour, and captured documents. The geography of the world expands faster than any one authority can reliably control it. Piri Reis appears to understand this instability. When he compiles his world map in 1513, he is not claiming to have sailed around the entire planet himself. Instead, he presents the map as a synthesis. Notes written directly onto the surviving parchment describe how he used a collection of earlier maps. These annotations are among the most important pieces of evidence in the entire mystery, because they show that the map is deliberately composite. He seems to have drawn from Portuguese charts, Arabic geographical traditions and other material circulating through Mediterranean networks. He also refers to a map connected in some way with Christopher Columbus. Whether he possessed an original chart used by Columbus, a copy or a later derivative remains uncertain, but the possibility alone illustrates how quickly geographic information could travel across political boundaries. The map itself is drawn on gazelle skin, a durable material well suited to valuable documents. The surviving fragment measures only part of what was once a larger world map. Much of the original is gone. This loss immediately creates a problem for later interpretation. Researchers are trying to understand a global design from a surviving piece. They can see a substantial part of the Atlantic world, but they cannot reconstruct with certainty how every region connected to the missing areas. What survives in the record suggests that the original map probably extended much farther east and north, perhaps including more of Europe, Asia, and the Mediterranean. Its disappearance leaves later viewers with an incomplete composition that can make unusual features seem more isolated than they originally were. The surviving fragment is visually dense. Decorative ships appear in the ocean, animals occupy interior regions. Place names and explanatory notes cover the parchment. Coastlines are rendered in the style of Portolan charts, the navigational maps that Mediterranean sailors had used for centuries. These charts are famous for their networks of radiating lines designed to help mariners follow compass directions between ports. Along familiar Mediterranean coasts, Portolan mapping could be remarkably effective. But when mapmakers attempted to extend those techniques across the Atlantic and onto a much larger world, new problems emerged. The central difficulty is that the Earth is curved and parchment is flat. This is obvious today, but solving it mathematically and practically is extremely difficult. A mapmaker has to choose what to distort. Shapes, distances, bearings, and areas cannot all be preserved perfectly on a flat surface. 16th century cartographers also struggle with inconsistent measurements collected from different voyages. Latitude can be estimated using the sun or stars with reasonable skill. Longitude is far harder because accurate determination requires precise knowledge of time differences between locations, something sailors cannot consistently achieve until the development of reliable marine chronometers centuries later. This means that two coastal surveys may each be useful locally, but fit together badly when combined. A stretch of coastline can become compressed, rotated, or extended. A cape may appear too far east. A river mouth may be shifted hundreds of kilometers. Islands may be duplicated because different sailors recorded the same island under different names or at different estimated positions. Such errors are not signs of incompetence. They are the predictable result of trying to build a global picture from incomplete observations taken under difficult conditions. Peary Rees works directly inside this problem. He has access to information that is unusually rich for his time, but richness does not mean consistency. His sources may use different scales, different conventions, different assumptions about distance, and different reference points. When he combines them, he has to make choices. Some features line up surprisingly well, others do not. The map therefore becomes a record not simply of what people know in 1513, but of how knowledge itself is being assembled. One lesser-known detail is that Peary Rees is not remembered only for this world map. He later produces the Kitab-ı Bahriye, often translated as the Book of Navigation, an extensive work describing Mediterranean ports, islands, coastlines, winds, hazards, and sailing routes. It combines practical maritime knowledge with maps and written observations. This later work demonstrates that he is not merely a collector of curiosities. He is an experienced navigator with a serious interest in geographic accuracy. He understands coastlines as living environments shaped by reefs, currents, harbours, shoals, and landmarks. His career makes the 1513 map easier to understand as a working synthesis of available knowledge rather than an isolated, mysterious artifact. At the same time, his competence does not eliminate uncertainty. In some places, the map appears remarkably informed. In others, it contains obvious distortions. This unevenness becomes important because later mystery writers often focus on the accurate-looking sections while treating the inaccurate ones as secondary. Historical cartographers tend to do the opposite. They examine the whole object and ask whether the unusual shapes can be explained by the normal limitations of the period. No single explanation fully accounts for every feature with perfect certainty, but there is no need to assume a vanished high-technology civilization simply because some coastlines look unexpected. The political context also helps explain why so many sources disappear. Geographic intelligence is valuable. Portuguese authorities attempt to control charts relating to their overseas routes. Spanish discoveries are similarly sensitive. Maps can reveal profitable trade winds, safe passages, resource-rich coasts, and strategic harbours. Copies circulate despite restrictions, but often through informal channels. Some survive in archives, many do not. A sailor's chart may be updated until it becomes unreadable. A royal document may be destroyed in war. A captured map may be copied and then discarded. Knowledge survives selectively. This makes Piri Reis unusually important. He sometimes preserves evidence of maps that no longer exist. His annotations act like fingerprints of missing documents. Even when historians cannot identify each source, they can see traces of a wider cartographic world behind him. That world is mostly gone, and here the mystery deepens without becoming supernatural. The astonishing thing is not that Piri Reis necessarily possessed a map from a lost Ice Age civilization. The astonishing thing is that he stands at the end of countless chains of copying that can no longer be reconstructed. Sailors measure coastlines. Mapmakers redraw them. Captains correct them. Charts are captured, recopied, renamed, and merged. By the time a line reaches the surviving parchment, its origin may already be obscure. The strange southern coast is therefore not a single clue standing alone. It is the product of an entire information system whose internal history is partly missing. To understand whether that coastline represents something extraordinary, the older charts behind Piri Reis must come into view, because his map openly admits that it is built from ghosts. Geographic documents that once existed influenced what he drew and then disappeared. Behind Piri Reis stands a vanished library of charts. Some are probably recent when he uses them. Others may already be copies of copies their original makers forgotten, long before the Ottoman admiral places his own ink on parchment. This is one of the most important facts in the entire story, because the 1513 map is not best understood as a single act of invention. It is a convergence point. Lines from different seas, different languages, and different centuries meet there. A coastline drawn by one sailor may pass through the hands of another navigator, then a merchant, then a military commander, then a mapmaker who has never seen the place himself. By the time it reaches Piri Reis, the line may still contain useful geographic truth, but its history has become almost impossible to recover. The Mediterranean has been producing geographic knowledge for thousands of years. Long before the Ottoman period, Phoenician sailors moved between ports across North Africa, the Levant Iberia, and beyond the Strait of Gibraltar. Greek geographers collect reports of distant lands. Roman administrators measure roads, provinces, and maritime routes. Later, Byzantine, Arab, Persian, Italian, Catalan, and Iberian navigators inherit and transform pieces of this accumulated knowledge. Most of their working charts do not survive. They are practical objects rather than sacred texts. They are used until they wear out. They are corrected in the margins, recopied when necessary, and discarded when newer information becomes available. The evidence remains incomplete precisely because useful maps are often destroyed by being useful. One major tradition that survives more clearly is the Portolan chart. These maritime maps emerge in the Mediterranean by the late Middle Ages and display coastlines with an accuracy that can still be striking today. They are covered by webs of rhumb lines radiating from compass points, allowing sailors to estimate directions between harbours. Familiar shorelines are often rendered in remarkable detail. Bays, capes, islands, and ports appear in sequences recognizable to modern eyes. Historians still debate exactly how the earliest Portolan tradition developed, because the first surviving examples already appear surprisingly mature. There is no preserved sequence showing every experimental stage that leads to them. That absence has encouraged speculation, but it does not require a lost advanced civilization. Maritime communities can accumulate precise knowledge without leaving behind an orderly archive of their learning process. Sailors repeatedly travel the same routes. Distances are estimated over many voyages. Compass bearings are compared. Errors are noticed when ships arrive too early, too late, or at the wrong headland. A coastline can gradually become accurate through practical correction even if nobody writes a theoretical explanation of the method. The finished chart survives. The generations of observations behind it do not. Piri Reis appears to inherit this working culture. His own later writings show strong familiarity with the Mediterranean, and his 1513 map reflects the visual language of maritime charts. Yet he is attempting something more ambitious. He is taking regional knowledge and pushing it into a representation of the wider world. That is where older geographic traditions begin to collide with the new Atlantic discoveries. Classical geography remains influential during this period. The work of Claudius Ptolemy, written in the 2nd century, survives through manuscript traditions and becomes enormously important again in Europe after being translated and printed. Ptolemy provides coordinates for thousands of locations and offers a mathematical framework for mapping the spherical Earth. But his world is incomplete. He underestimates the circumference of the planet, knows nothing of the Americas. His Indian Ocean is enclosed by imagined land in some reconstructions. Even a sophisticated ancient system can carry major errors forward for centuries. This reveals an important pattern. Old information is not automatically superior information. A mapmaker working in 1513 may have access to an ancient geographic idea, a medieval coastal chart, and a fresh Portuguese survey all at the same time. One source may be highly accurate in one region and completely wrong in another. Combining them is not simply a matter of selecting the oldest material, it is an act of judgment. Piri Reis says that he used around 20 charts and mappae mundi of various kinds. His notes refer to sources associated with Alexander the Great's time Arab maps, Portuguese charts, and a map connected with Columbus. The exact meaning of some of these statements is difficult to interpret. A map described as coming from the time of Alexander does not necessarily mean that Piri Reis physically possesses a parchment made in the 4th century BCE. It could refer to a geographic tradition believed to descend from ancient authorities. Medieval scholars often attribute knowledge broadly to famous figures from antiquity. Scholars still debate how literally certain annotations should be read. The reference to Columbus is especially intriguing. Piri Reis describes information about the western lands that appears to derive from a chart used by Columbus or from someone who had sailed with him. There is a plausible historical pathway for such material to reach Ottoman hands. Spanish ships and crews operate in a Mediterranean world connected by war, piracy, enslavement, trade, and intelligence. Captured sailors can carry information across political boundaries. A chart does not need to move through official diplomacy to travel hundreds of kilometers. This helps explain why some parts of the surviving map resemble early European representations of the Caribbean and South America. It also explains their errors. Columbus himself interprets the lands he encounters through assumptions inherited from older geography. He dies believing he has reached regions connected with Asia. Early maps of the Americas are created during a period when cartographers are still uncertain whether newly encountered coasts belong to island Asia or an entirely separate continental system. Piri Reis is drawing while this debate is still alive. One surprising detail is how quickly mistakes can become authoritative once they appear on a chart. If a respected navigator places an island in the wrong location later, mapmakers may copy it rather than remove it. Phantom islands survive on maps for centuries. Some are based on misidentified clouds, ice-duplicated real islands, or simple navigational error. Others may originate in legends. Once printed or copied repeatedly, they acquire a kind of geographic reality on paper long after sailors fail to find them. The same process can affect coastlines. A mapmaker may stretch a shore to connect two pieces of information whose relationship is uncertain. If longitude estimates are wrong, coastlines can overlap or curve unnaturally. A southern extension of a known continent can become exaggerated as the mapmaker tries to fit incomplete surveys together. Later, viewers armed with modern maps may see resemblance where the original cartographer saw only unresolved geography. There is another complication. Early world maps are not always built according to a single consistent projection. Different source charts can be combined visually without mathematically transforming every coordinate into one unified system. The result can look coherent at first glance while containing internal distortions. This is particularly important when evaluating claims that an ancient or early modern map shows an unknown continent. Modern comparisons often place the old image beside a satellite map and search for matching outlines. But coastlines are flexible under projection, rotation, scaling, and selective interpretation. With enough adjustment, two unrelated shapes can appear surprisingly similar. None of this removes the mystery of the lost sources. In fact, it makes them more interesting. Piri Reis gives modern historians a glimpse of an archive that no longer exists. Somewhere behind his parchment are Portuguese charts from the first decades of Atlantic exploration. There may be information copied from Spanish sources. There are Mediterranean navigational traditions whose origins are only partly understood. There are older geographical ideas filtered through Arabic and classical scholarship. Each source contributes something, yet almost none can be reconstructed completely. The picture is therefore less like a secret master map passed intact across thousands of years, and more like a river system. Knowledge flows through many channels. Some streams are ancient, others are recent. They merge, divide, disappear underground, and emerge again in altered form. A line on the 1513 parchment may carry a memory much older than Piri Reis, without preserving any clue about how many hands transmitted it. That distinction is crucial. Information can be old without being impossible. A coastline can descend from generations of sailors without implying prehistoric global navigation. At the same time, the loss of those generations means modern historians must work with fragments. There will always be spaces where certainty ends, and it is inside one of those spaces that the southern coastline begins to attract attention. Once the map is understood as a mosaic assembled from missing charts, the temptation becomes obvious. If some sources are older than expected, perhaps one of them preserved knowledge of a world that had vanished entirely. But before that possibility can be judged, it is necessary to understand how maps themselves change as they are copied, corrected, and stretched across the curved surface of the earth. A map can look like a statement of certainty even when it is really a record of compromise. Ink gives coastlines sharp edges. Mountains stand where the mapmaker places them. Islands appear as fixed objects. To a modern viewer, especially one accustomed to satellite imagery and digital coordinates, the finished image can feel authoritative. But early maps are often far more fluid than they appear. They are living documents shaped by repetition, correction, copying, inheritance, and error. A coastline may survive for centuries not because every mapmaker personally confirms it, but because each generation accepts enough of the previous generation's work to keep drawing it. This is one of the most important ideas for understanding the strange southern shore on the Peary Race map. Long before global navigation becomes routine, sailors already depend on regional charts that are constantly tested against experience. A captain approaching Sicily, Crete, Majorca, or the Levant can compare what he sees with the sequence of capes and harbours marked on a chart. If a bay is drawn badly, the mistake matters. If a dangerous shoal is missing, the mistake matters even more. Familiar routes, therefore, encourage correction. Repeated travel exerts pressure on maps to become useful. This is one reason medieval Portolan charts can represent heavily travelled Mediterranean coastlines with surprising accuracy. They are products of accumulated experience, not isolated acts of genius. The farther a map stretches beyond familiar routes, however, the weaker that corrective pressure becomes. A coastline seen once under poor weather may be drawn from uncertain estimates. A captain may record a landfall without knowing exactly where he is. A mapmaker may receive two accounts of the same shore and assume they describe different places. Another may combine reports from separate voyages that were measured using different scales. The resulting chart can still be useful, but distortions begin to enter the system. Copying magnifies this effect. In the centuries before standardized modern cartography, reproducing a map often means tracing or redrawing it by hand. Even careful copying introduces slight shifts. A curve becomes smoother, a cape becomes larger, a group of islands moves a few millimeters. On a small regional chart, these changes may be minor. After several generations of copying, however, they can accumulate. When a mapmaker then merges that copied chart with information from another tradition, the coastline may be altered again. Names create their own confusion. The same island may carry several names in different languages. A harbour known to Arab sailors may appear under another form on an Italian chart and another on a Portuguese one. A mapmaker unfamiliar with the relationship between those names can duplicate the feature. This helps explain why phantom islands become a recurring phenomenon in cartographic history. Some remain on maps for hundreds of years despite repeated failures to locate them. Once an object enters a respected geographic tradition, removing it can require more confidence than copying it. There is a subtle psychological reason for this. Empty space makes mapmakers uncomfortable. A blank region does not merely communicate ignorance. It can make the whole map feel unfinished. Medieval and early modern maps often fill unknown territory with decorative mountains, legendary peoples, speculative rivers, animals, or imagined land. This does not mean cartographers are dishonest. A map serves cultural and political purposes as well as navigational ones. It is a picture of how the world is understood, not simply a technical measurement sheet. The southern parts of world maps are especially vulnerable to speculation. Ancient Greek thinkers already reason that large land masses might exist in the south. One argument is based on symmetry. If so much land occupies the northern hemisphere, perhaps southern land is needed to balance the globe. Later cartographers inherit versions of this idea, eventually representing a vast hypothetical southern continent, often called Terra Australis. For centuries it appears on maps before the true geography of Antarctica and Australia is known. This detail matters because the existence of southern land on an old map does not automatically prove that sailors had seen it. Sometimes the land is theoretical. It is drawn because geography is expected to contain it. Early maps can therefore combine observation and prediction in the same image without clearly distinguishing between them. Modern viewers trained to assume that mapped coastlines represent surveyed coastlines can easily read more certainty into these shapes than the original mapmaker intended. Projection adds another layer of distortion. The Mediterranean Portolan tradition works well across a limited region because the curvature of the Earth creates relatively manageable errors at that scale. Extending the same navigational logic across the Atlantic is far more difficult. Distances become larger, differences in latitude become more important, and longitude remains uncertain. A mapmaker, assembling coastlines from multiple sources, can preserve local detail while seriously misplacing the overall shape. Imagine several strips of coastline drawn on separate pieces of parchment. Each strip contains useful information, but each was measured differently. One is slightly too long, another is rotated, a third is shifted east. The task is to join them into a single continuous shore. There may be no mathematically perfect solution. The mapmaker bends one section, compresses another, and attaches a third where the available information seems to fit. The final coast is recognizable in parts yet strange as a whole. Something very much like this can happen in early representations of South America. The Atlantic coast is gradually becoming known during the first decades of the 16th century, but its southern extent remains uncertain. Explorers have not yet produced the comprehensive surveys that later generations will use. The Strait of Magellan is not crossed by Europeans until the expedition beginning in 1519, years after the Piri Reis map is compiled. Knowledge of the far southern coastline is therefore fragmentary in 1513. This creates a practical cartographic problem. A mapmaker knows that the South American coast continues southward, but does not know precisely how far or how it turns. One solution is simply to extend it. If space on the parchment is limited, the coastline may bend eastward along the bottom edge. Such a bend can later look like an entirely separate southern continent when compared with the modern geography. Scholars who reject the Antarctica interpretation often point toward this possibility. The controversial southern coast can be understood as a distorted continuation of South America, rather than a representation of land beneath Antarctic ice. Certain place names and geographic features appear to support the South American reading. The orientation is strange, but strange orientation is not unusual in composite maps produced from inconsistent data. The evidence remains incomplete, yet the conventional explanation requires fewer, extraordinary assumptions. Another revealing feature of early mapping is the treatment of scale. Modern maps usually maintain a mathematically defined relationship between distance on paper and distance on Earth. Older charts can be less consistent. One region may effectively be drawn at a different scale from another. This is especially likely when several source documents are combined. A coastline can therefore be locally convincing while globally distorted. The surprising part is that sailors can still use such charts. Navigation does not always require perfect continental geometry. A mariner travelling between known ports cares intensely about bearings, landmarks, islands, and harbour approaches. Whether a distant continent is shown with the exact modern outline may matter less. Practical accuracy and global accuracy are not the same thing. This helps explain why the Piri Reis map can contain features that appear sophisticated beside others that seem dramatically wrong. There is no contradiction. The map is carrying information of different quality from different sources. Some observations have been tested repeatedly, others may be speculative. Some coastlines may preserve recent Portuguese knowledge, others may inherit older geographic assumptions. The parchment gathers all of them into one visual field, making them look more unified than their histories really are. What survives in the record suggests that this process is normal rather than exceptional. Maps evolve by inheritance. Errors can travel as easily as discoveries. A shape that looks impossible may simply be an ordinary coastline transformed by scale projection, uncertainty, and repeated copying. But there is one shape on the Piri Reis map that later observers refuse to treat as ordinary. Once modern Antarctica becomes known, the bent southern coastline begins to attract a new interpretation. To some eyes, it no longer resembles an imperfect South America. It resembles something far more astonishing, the edge of a continent that Europeans were not supposed to know existed at all. The controversial coastline begins where certainty starts to weaken. South America descends along the parchment with enough recognizable detail to anchor the eye, and then toward the bottom the land turns sharply eastward. To modern viewers, this bend is the moment the map seems to break its own historical limits. The familiar continent appears to transform into something else, a broad southern shore, extending across the lower edge of the surviving fragment. For those who later become convinced that Piri Reis preserved knowledge of Antarctica, this is the decisive clue. The argument is simple in outline and astonishing in implication. The map supposedly shows part of the Antarctic coastline centuries before the continent was officially sighted, and perhaps even depicts it without the massive ice cover that hides much of its underlying shape today. The idea gains power because the southern edge is genuinely strange. It does not resemble a clean modern outline of South America. Its orientation looks wrong. Some bays and projections invite comparison with the coast of Antarctica. If the map is rotated, stretched, or interpreted through particular projection models, certain points can be made to resemble modern geographic features. To a viewer already expecting a hidden continent, the similarity can feel persuasive. But resemblance is not the same as identification, and historical cartography is full of shapes that become convincing only after the desired match is chosen. The first problem is chronology. Piri Reis completes the map in 1513. European navigators have already reached and mapped substantial portions of the eastern coast of South America, but Antarctica remains outside documented European geographic knowledge. The first confirmed sightings of the Antarctic continent occur only in the early 19th century. If the southern land on the Piri Reis map truly represents Antarctica, then the information must come from an earlier source whose existence is otherwise unknown. This does not make the claim logically impossible, but it raises the evidentiary standard dramatically. An extraordinary reinterpretation of world exploration requires more than an approximate visual resemblance. The second problem concerns what Piri Reis himself appears to think he is drawing. Place names and annotations in the southern region seem more naturally connected with South American geography, and with reports circulating during the early age of Atlantic exploration. The coastline does not suddenly announce itself as an unknown polar continent. Instead, it seems to continue the geography already unfolding above it. This is one reason mainstream historians usually interpret the eastern turning land as a distorted continuation of South America, compressed or curved to fit the available parchment and the mapmaker's source material. Such distortions are entirely plausible in 1513. The southern limits of South America are poorly understood by Europeans at this date. Ferdinand Magellan's expedition will not enter the strait that now bears his name until 1520. The relationship between the Atlantic and Pacific Oceans around the southern tip remains unresolved in Piri Reis's world. A cartographer working with incomplete Portuguese and Spanish reports may know that the coast continues but have no reliable way to position its farthest reaches. If longitude errors accumulate, the continent can become dramatically warped. There is also the physical shape of the surviving map to consider. The fragment is not an unlimited blank sheet. Coastlines have to fit within a designed composition. Mapmakers sometimes bend or compress geography when space runs out. This is not unusual even in otherwise sophisticated maps. A coastline placed near the edge may turn because the parchment ends, because the source chart is oriented differently, or because the mapmaker chooses to preserve certain local details while sacrificing overall geometry. One of the more revealing comparisons comes from other maps made around the same era. Early 16th century cartography contains many uncertain representations of South America. Some show its lower coastline extending strangely east or west. Others attach speculative southern lands to known continents. The shape of the world is still being negotiated. It is easy to forget this because modern maps create the illusion that continental outlines have always been obvious. In 1513 they are not. The Antarctic interpretation becomes much more dramatic when it adds a second claim that the map shows the continent before it was covered by ice. This idea suggests that the source map must be immensely ancient, perhaps dating to a period when portions of Antarctica were exposed. But geological evidence creates serious problems for that scenario. Antarctica has supported extensive continental ice for millions of years, although the size and behavior of its ice sheets have changed through deep time. There is no accepted evidence for a human civilization mapping an ice-free Antarctic coastline within the time frame of Homo sapiens. The idea therefore moves far beyond an unexplained map feature and into a chain of assumptions unsupported by archaeology or geology. This is where the distinction between mystery and evidence becomes essential. A strange coastline is real. The missing sources are real. The incomplete nature of early global mapping is real. But from those facts, it does not automatically follow that a prehistoric civilization surveyed Antarctica. Each additional claim needs its own independent support. Without artifact settlements, navigation instruments, inscriptions, datable charts, or other archaeological traces, the theory remains speculative. There is another complication that rarely appears in popular retellings. Coastlines themselves are visually deceptive. A person comparing two irregular outlines can find similarities almost anywhere if rotation and scale are flexible enough. Human pattern recognition is powerful precisely because it is designed to find structure in incomplete information. This ability helps identify faces, tracks landscapes and danger, but it can also produce false matches. Cartographic comparisons are especially vulnerable because coastlines contain endless curves, bays, and projections. Select a handful of matching points and ignore the ones that fail, and almost any broad resemblance can begin to look meaningful. Researchers therefore ask more demanding questions. Do the relative distances between supposed matching features agree? Do the place names fit? Does the orientation make sense under a plausible projection? Do nearby coastlines become more accurate or less accurate under the same transformation? Can the proposed mapping method be demonstrated consistently across the whole map rather than only in the most suggestive region? When these tests are applied, the Antarctica argument becomes much weaker. The alternative South American explanation has its own imperfections. No reconstruction makes every line fall neatly into place. The coastline remains odd, but historical explanations do not need perfect modern accuracy. They need to fit the conditions under which the object was made. An early 16th century map assembled from inconsistent charts, uncertain longitudes, incomplete exploration, and limited space should be expected to contain distortions. The surprising thing would be if it did not. A lesser-known element of the debate is how much the mystery depends on modern expectations. Early viewers of the map did not immediately identify its southern section as Antarctica. The connection becomes prominent only after the continent itself is known, and after modern maps of its coastline exist for comparison. In other words, the interpretation is retrospective. A new geographic object is projected backward onto an older ambiguous shape. That does not automatically make the comparison wrong, but it means the historical context of the interpretation matters. There is a broader lesson here. Old maps often appear prophetic because modern viewers know what came later. A vague island can look like Australia once Australia is known. A speculative western coast can look like America after Columbus. An imagined southern continent can resemble Antarctica after Antarctica enters modern geography. The danger is reading future knowledge into past uncertainty, and yet the appeal remains difficult to dismiss emotionally. The map survives from a moment when enormous parts of the world are still being redrawn. Its sources are partly lost. Its southern edge looks unresolved. This creates exactly the kind of gap in which extraordinary ideas flourish. The parchment offers enough uncertainty to invite speculation, but not enough information to close the case completely. That unresolved quality is why the Antarctica theory takes hold so powerfully in the centuries that follow. Once the strange coastline is no longer seen merely as a cartographic distortion, but as a possible remnant of forbidden knowledge, the map becomes something larger than a Renaissance artifact. It becomes a supposed message from a civilization that should not exist, and the story begins to move far beyond Piri Reis himself. By the 20th century, the strange southern coastline has acquired a life far beyond the parchment that carries it. The map is no longer discussed only as a product of Ottoman navigation or early Atlantic exploration. It begins to appear in books about lost civilizations, forgotten technologies, and ancient global knowledge. The central claim grows more ambitious with every retelling. Perhaps Piri Reis did not merely preserve a distorted coastline. Perhaps he copied a much older chart. Perhaps that older chart was created when Antarctica was largely free of ice. Perhaps an unknown civilization once possessed the mathematics, navigation, and surveying ability required to map the planet thousands of years before recorded history. The theory is compelling because every missing source becomes a door through which another possibility can enter. One influential version of this argument emerges in the 20th century, when researchers attempt to compare the Piri Reis map with modern maps of Antarctica. They notice that parts of the southern coastline can be made to resemble areas along Queen Maud Land and other sections of the Antarctic margin, if the old map is rotated and interpreted through particular assumptions about projection. Some writers go further, arguing that the map reflects the shape of the land beneath the ice rather than the visible ice-covered coast. This transforms the mystery dramatically. If the parchment truly contains subglacial geography, then whoever created the original source must somehow have known the shape of Antarctica before modern geophysical surveys. That possibility becomes particularly attractive after scientists begin using seismic measurements, radar, and other techniques to investigate the continent beneath its ice. Antarctica is not simply a flat frozen platform. Beneath the ice lies an extraordinary landscape of mountain ranges, deep basins, valleys, and buried terrain. In some places, the bedrock surface sits far below sea level. In others, mountains rise beneath kilometers of ice. Modern maps of this hidden topography can look striking, and comparisons with old cartographic outlines can become visually seductive. But the scientific chronology creates a major obstacle. Antarctica has not been a recently ice-free continent waiting within the time frame of human civilization. Geological evidence indicates that major Antarctic glaciation began tens of millions of years ago. Ice sheets have expanded and contracted many times since then, but the idea that a technologically advanced human society surveyed a largely ice-free Antarctica several thousand years ago conflict with the known geological record. Homo sapiens appears vastly later in time. There is no accepted archaeological evidence placing prehistoric humans in Antarctica, much less a civilization capable of systematic continental mapping. Supporters of the lost map theory sometimes respond by proposing that the ancient source records only sections of coastline that were temporarily less glaciated, or that the map originated at some remote period not yet understood. But each adjustment creates additional assumptions. There must be a civilization without known cities, tools, ships, ports, inscriptions, or settlements. It must possess sophisticated geographic knowledge. Its maps must survive for thousands of years through unknown chains of transmission. The original civilization must disappear while somehow allowing fragments of its cartography to reach classical or medieval mapmakers. Finally, those fragments must reach Piri Reis without leaving a clear documentary trail. No single explanation fully accounts for this chain with independent evidence. The problem is not that ancient people were incapable of impressive navigation. They clearly were. Humans cross open water long before written history. The settlement of Australia requires sea crossings tens of thousands of years ago. Austronesian navigators later spread across enormous distances in the Pacific, using stars, swells, winds, clouds, birds, and accumulated environmental knowledge. Phoenician and Greek sailors travel widely through the Mediterranean and beyond. These achievements are extraordinary without needing to be transformed into evidence for prehistoric mapping of Antarctica. Navigation and global cartography are also different abilities. A society can travel enormous distances without creating a mathematically accurate map of the entire Earth. Polynesian navigation demonstrates this vividly. Navigators can carry highly sophisticated spatial knowledge in memory and tradition, reading ocean patterns with precision while representing space through systems very different from modern coordinate maps. The existence of remarkable sailors therefore does not automatically imply the existence of modern-style global surveys. Another difficulty concerns the supposed accuracy of the Antarctic match. If the Piri Reis coastline truly comes from a precise ancient survey, its geometry should behave consistently. Features should align not only in selected areas, but across the proposed coastline. Distances, orientations, capes, bays, and relative positions should correspond under a plausible cartographic transformation. Instead, the identification tends to depend on selective comparison. Some parts are emphasized because they resemble modern features. Other parts that do not fit are treated as distortion. This is a common problem in historical map mysteries. When an old image contains an irregular coastline, a researcher can choose a modern coastline that resembles it, rotate one image, alter scale, and search for matching points. The human eye is exceptionally good at finding similarities, but a scientific comparison must also count mismatches. If 10 features disagree and 3 appear similar, the 3 similarities cannot be treated as decisive evidence simply because they are visually dramatic. There is also the issue of what Antarctica actually looks like beneath the ice. The phrase ice-free Antarctica can be misleading. Remove the modern ice sheet and the continent would not instantly reveal the same coastline shown on current subglacial maps. The enormous weight of the ice depresses the crust. If the ice disappeared, the land would gradually rebound. Global sea levels would rise dramatically. Parts of the continent that are currently grounded below sea level would become marine basins. The resulting shoreline would change over time. Therefore, matching an old drawn coastline to a modern reconstruction of Antarctic bedrock is much more complicated than simply comparing outlines. This detail is often overlooked because the lost world theory works best when Antarctica is imagined as a fixed object, hidden beneath a removable white covering. In reality, ice, rock, and sea interact dynamically. The coastline itself depends partly on ice thickness, crustal depression, sea level, and geological response. A prehistoric map supposedly showing an ice-free continent would have to correspond to a specific environmental state, not merely to today's bedrock topography. Climate evidence creates further problems. Although Antarctica experiences warmer intervals in deep geological time, those intervals occur long before human civilization. Fossils show that forests once existed there, but these belong to ancient epochs separated from humans by tens of millions of years. The fact that Antarctica was once green is scientifically real. The idea that people witnessed and mapped that green, Antarctica is not supported by evidence. Mixing those two statements can make a speculative theory sound more plausible than it is. The archaeological silence is even more significant. A civilization capable of charting distant continents would presumably produce material traces somewhere. Settlements, shipbuilding facilities, specialized tools, trade networks, navigational instruments, written records, or distinctive artifacts distributed across large areas. Archaeology has uncovered civilizations that were forgotten for thousands of years, but none leaves absolutely nothing. Even mobile populations leave stone tools, hearths, bones, waste deposits, and genetic traces. Large maritime societies leave more. This does not mean history contains no missing civilizations. Many societies remain poorly understood. Entire settlements lie beneath modern cities, deserts, forests, and seas. Archaeologists continue to discover cultures whose scale was previously underestimated. Yet there is a difference between saying that unknown societies probably existed and saying that one of them mapped Antarctica. The first follows naturally from the incompleteness of the archaeological record. The second requires specific evidence that has not appeared. The Piri Reis map remains fascinating precisely because it does not need the Antarctic theory to be remarkable. It genuinely preserves a moment when the known world is being reconstructed from fragments. It genuinely refers to older sources that are lost. It genuinely contains geographic distortions whose exact origins cannot always be identified. These are authentic mysteries. They are smaller than the idea of a vanished global civilization, but they are also more firmly connected to the evidence. And there is an irony hidden inside the debate. While generations have searched the parchment for an impossible, ice-free Antarctica, scientists have discovered that Antarctica itself does contain a lost world beneath its ice-buried mountains, ancient valleys, hidden lakes, and landscapes isolated for immense spans of time. The real continent beneath the frozen surface is stranger than the speculative map story in many ways. Understanding that hidden geography makes it possible to see why the old comparison is so seductive, but also why the resemblance cannot carry the extraordinary historical weight placed upon it. Beneath the white surface of Antarctica lies a continent that would have seemed almost impossible to imagine when Piri Reis drew his map. The ice creates the illusion of simplicity. From above, much of the land appears as an immense frozen plateau, broken by mountain ranges, glaciers, and coastal shelves. Yet remove that ice conceptually and a far more complicated world emerges. Hidden below are deep valleys, high mountain systems, enormous basins, ancient river-shaped landscapes, and regions whose bedrock lies far beneath present sea level. In some places the ice is several kilometers thick. The visible coastline is therefore only the outer boundary of a much larger geological system, one whose true structure has been revealed gradually through modern science. This buried geography has helped fuel the fascination surrounding the Piri-Reis map. When 20th century researchers began comparing the mysterious southern coastline with reconstructions of Antarctic terrain, the possibility seemed almost cinematic. Perhaps the old parchment did not show the modern ice-covered edge at all. Perhaps it preserved the shape of the continent beneath the ice. If so, the map would represent knowledge inaccessible to ordinary sailors and unavailable until modern geophysical techniques. The idea transforms a 16th century document into something resembling a scientific anomaly, but modern understanding of Antarctica makes the comparison far less straightforward than it first appears. The continent beneath the ice is not simply a hidden coastline waiting to be traced. Much of the bedrock is depressed by the enormous weight of the ice sheet. Some regions would rise gradually if the ice disappeared, a process known as isostatic rebound. At the same time, melting Antarctica would contribute dramatically to global sea level rise. These two changes would reshape the boundary between land and sea. An ice-free Antarctica would therefore not possess one simple permanent outline. Its coastline would depend on when the ice disappeared, how the crust responded, and how global oceans adjusted. West Antarctica is particularly complicated. Large portions of its bedrock lie below sea level. Without the modern ice sheet, some areas might become a complex arrangement of islands and marine basins, rather than a single solid continental edge. East Antarctica contains more extensive high terrain, but even there the hidden landscape is deeply irregular. Subglacial mountain ranges rise beneath the ice, while enormous valleys cut through regions that have been concealed for millions of years. Any claim that an old map represents this geography must therefore specify exactly which version of Antarctica it is supposed to depict. Modern scientists reconstruct the buried landscape using methods far beyond anything available to early navigators. Aircraft and satellites carry ice-penetrating radar capable of measuring the thickness of the ice and estimating the position of bedrock below. Seismic techniques reveal geological structures by studying how waves move through ice and rock. Gravity measurements help identify variations in underlying mass. Decades of surveys are combined into increasingly detailed models of Antarctic topography. Even today, these reconstructions continue to improve. Some remote regions remain less precisely mapped than more accessible ones. This makes the supposed ancient achievement even more demanding. A prehistoric civilization would not merely need to reach Antarctica. If the Piri-Reis map truly represented subglacial terrain, that civilization would somehow need access to geographic information now obtained through technologies designed specifically to penetrate ice. The alternative is that the ancient source dates from a period before the ice existed in its present form, but that immediately collides with geological time. Antarctica was not always frozen. This part is firmly established. Fossils and sedimentary evidence show that forests once grew on the continent. During much warmer periods of Earth's deep past, Antarctica supports vegetation and ecosystems radically different from those of today. Dinosaurs once inhabit Antarctic landscapes. Later mammals and forests persist during warmer geological epochs. The continent gradually becomes more isolated as surrounding ocean circulation changes and atmospheric carbon dioxide levels decline. Major Antarctic glaciation begins roughly 34 million years ago, around the transition between the Eocene and Oligocene epochs. The ice sheet changes repeatedly after that, sometimes expanding and retreating as global climate fluctuates. But these transformations occur on geological timescales overwhelmingly older than human civilization. Homo sapiens does not appear until hundreds of thousands of years ago, not tens of millions. Even the earliest known members of the genus Homo arise only a few million years ago. The green Antarctica revealed by fossils belongs to a planet on which humans do not yet exist. This is a crucial distinction because popular discussions sometimes compress deep time into a vague ancient past. A statement that Antarctica was once ice-free is true. A statement that humans mapped it while it was ice-free is entirely different. Between these two ideas lies a gap of millions of years. Geological evidence does not close that gap, it makes it larger. There have been periods during the human era when Antarctic ice margins differed from today, and ice sheets are dynamic rather than completely static. But there is no evidence for a recent epoch in which the continent was broadly free of ice and available for human coastal surveying. The evidence remains incomplete in many details of ancient climate, yet the overall chronology is sufficiently well established that a Holocene civilization mapping a largely ice-free Antarctica is not supported. The hidden landscape itself contains astonishing discoveries that require no lost civilization to make them mysterious. Beneath the ice are subglacial lakes, isolated from direct contact with the atmosphere for immense periods. Lake Vostok is the most famous, lying beneath roughly 4 kilometers of ice in East Antarctica. Hundreds of other subglacial lakes have been identified. Water can move between some of them beneath the ice sheet, creating a concealed hydrological network unlike anything visible at the surface. Scientists have also identified ancient landscapes preserved beneath the ice with relatively little erosion. Valleys and ridges can remain frozen in place for millions of years, almost like geological time capsules. In some regions, researchers believe the buried terrain preserves evidence of rivers that flowed before major glaciation transformed the continent. These are genuine lost worlds, though not lost human worlds. They belong to a far deeper history of Earth. This is perhaps why Antarctica attracts so much speculation. It is physically remote, visually inaccessible, and literally conceals a continent beneath ice. Few places on Earth create such a natural sense that something enormous is hidden. When an ambiguous old coastline is placed beside this landscape, the imagination has almost everything it needs. A damaged map missing sources a buried continent, and an age before modern exploration form a perfect structure for mystery. But scientific mystery operates differently from speculative mystery. Scientists do not begin with the assumption that the old map must show Antarctica, and then search for matching features. They begin with what is known about the document, the geography, the ice history, and the techniques available in 1513. Each proposed identification has to survive those constraints. When those conditions are applied, the Antarctic explanation becomes increasingly difficult to sustain. The strange southern shore is more naturally explained by the cartographic world already surrounding Piri Reis, incomplete knowledge of South America, uncertain longitude, mixed source maps, projection distortions, and the habit of extending land into regions not yet fully explored. None of these factors is exotic. Together they can create a coastline that looks far more mysterious centuries later than it probably appeared to its maker. And yet Antarctica contributes something important to the story, even if it is absent from the map. It demonstrates that entire landscapes can truly disappear from human sight. Mountains can vanish beneath ice. Valleys can remain hidden for millions of years. Rivers can leave traces beneath frozen sheets. The planet can preserve enormous worlds while making them effectively invisible. The same principle applies elsewhere, but on a timescale directly connected to human life. At the end of the last ice age, coastlines across the planet move inward as sea levels rise. Unlike Antarctica's ancient buried terrain, many of those drowned landscapes are inhabited by people. Their rivers, hunting grounds, migration routes, and perhaps settlements disappear beneath the sea. The ancient map may not show one of those worlds, but the Earth itself still carries their outlines beneath modern water. The ocean has not always begun where it begins today. Around 20,000 years ago, near the height of the last ice age, enormous quantities of water are locked inside continental ice sheets. Sea level stands more than 100 meters lower than it does in the modern world. The difference is large enough to redraw entire regions of the planet. Shallow seas become plains, islands merge into continents, rivers flow across landscapes that now lie beneath waves. Coastlines extend outward for tens or even hundreds of kilometers. To the people living, then, these were not temporary margins waiting to be drowned. They were ordinary homelands, grasslands, marshes, valleys, hunting grounds, estuaries, and migration corridors that could support generations of human life. This is the kind of lost world that requires no forgotten super-civilization. It is written into geology. As global temperatures rise after the Ice Age glaciers retreat and meltwater returns to the oceans, sea level climbs in stages over thousands of years. The process is not uniform. There are periods of faster rise and periods of relative stability, but the long-term direction is relentless. A beach becomes a tidal flat. A tidal flat becomes a lagoon. A river valley becomes an estuary. Eventually, the sea covers the place completely. For communities whose lives depend on particular freshwater sources, fishing grounds, animal routes, or coastal plains, even a gradual change can force repeated movement. The transformation is difficult to imagine from a modern coastline because the sea conceals its own history. Standing on a beach today, the horizon appears permanent, yet beneath that water may lie the surface of a former plain. Sediment cores can reveal ancient soils. Sonar can trace buried river channels. Fishermen sometimes recover bones or stone tools from areas now far offshore. These discoveries show that the edge of the modern continent is not necessarily the edge of the ancient human world. One of the clearest examples lies between Britain and continental Europe. Today, the North Sea separates the British Isles from the Netherlands, Germany, and Denmark. During the Ice Age and for thousands of years afterward, much of that region is dry land. Archaeologists and geologists call this vanished landscape Doggerland. It is not a narrow bridge crossed quickly by migrating groups. At times, it is an extensive inhabited region of rivers, wetlands, woodland, and open terrain. Animals move across it. Human communities hunt, gather fish, and travel through it. Britain is not yet an island in the modern sense. As the climate warms, Doggerland changes gradually. Rising seas flood lower areas. What was once a broad plain becomes increasingly fragmented. Wetlands expand. Higher ground remains as islands for a time. Eventually, almost the entire region disappears beneath the North Sea. A large submarine landslide known as the Storegga Slide off the coast of Norway, roughly 8,000 years ago, generates a major tsunami that strikes parts of the remaining coastal landscape. It was once sometimes described as a final catastrophic end for Doggerland, though modern research suggests the drowning process was more complex and already well advanced. Scholars still debate exactly how many people occupied the region at different stages and how the tsunami affected surviving communities. The important point is that a vast human landscape really vanishes from sight. There are no medieval chronicles describing it. No detailed maps survive from its inhabited period. Much of its archaeology lies underwater where research is difficult and expensive. If geology had not reconstructed the former coastline, the scale of the lost region would be far harder to imagine. Far to the southeast, an even larger transformation occurs across what is now maritime Southeast Asia. During periods of lower sea level, the islands of Sumatra, Java, and Borneo are connected with mainland Southeast Asia through a broad exposed shelf known as Sunderland. The geography of the region is radically different. Large rivers cross the plain. Animal populations move through connected habitats. Human groups can travel across areas that later become separated by ocean. As sea levels rise, this immense lowland is progressively flooded. Mountains become islands. River valleys become straits and shallow seas. Populations that once occupy a continuous landscape are divided by expanding water. Genetic and archaeological evidence suggests complex movements and interactions across the region, although the precise relationships between sea level rise migration and cultural change remain under investigation. What survives in the record suggests that the drowning of Sunderland must have transformed human geography on a scale difficult to overstate. The Persian Gulf provides another striking example. During periods of lower sea level, much of the shallow basin is exposed. Rivers from Mesopotamia and surrounding regions flow across a landscape where the modern Gulf now exists. Some researchers have proposed that this basin may have offered attractive environments for prehistoric communities before marine waters gradually flooded it. The exact scale and density of occupation remain uncertain, because much of the relevant terrain is inaccessible beneath water and sediment. But the geological fact of exposure is clear. Around the world, similar changes occur on continental shelves. The Adriatic Sea is smaller. The Black Sea coastline differs. Australia is connected with New Guinea as part of the larger landmass known as Sahel, though deep water crossings are still required for the first human arrival there. Japan has different coastal configurations. The Bering region contains an enormous exposed landscape connecting northeastern Asia and Alaska, commonly called Beringia. It serves not simply as a narrow bridge, but as a broad ecological zone that exists for thousands of years. These lost landscapes alter how prehistory must be imagined. Archaeology has traditionally been easier on dry land, so surviving sites naturally cluster within present coastlines. But ancient people often favour coasts, estuaries, river mouths and wetlands because such environments provide diverse food resources and transportation routes. Many of the places most attractive to prehistoric communities are therefore among the places most likely to have been submerged when sea levels rose. This creates a major preservation bias. Archaeologists may be trying to reconstruct human migration and settlement from a map with some of its richest zones missing. The absence of coastal sites from certain periods does not necessarily mean that people avoided the coast. The coast they used may simply be underwater now. Stone tools can survive beneath marine sediments, but finding them across vast seabeds is extraordinarily difficult. Organic materials such as wood fibre and plant remains usually disappear unless preserved under exceptional conditions. The rising ocean also changes cultural memory. A community may move inland repeatedly over generations, each time leaving behind places associated with ancestors. A hill becomes an island. A familiar river mouth disappears. A sacred or socially important location may pass beneath water. No single generation necessarily watches an entire country vanish, but the direction of change can still be experienced across collective memory. It is tempting to imagine such communities drawing precise maps of the lost coastlines, but there is no evidence that Ice Age people produced world maps resembling early modern cartography. Their geographic knowledge may instead have been carried through routes, stories, landmarks, seasonal movements, and remembered relationships between places. A lost world does not require a surviving parchment to have been remembered. This is where the Puri Reis mystery quietly changes character. The old map probably does not preserve an Ice Age coastline. Yet the broader idea behind the legend that human beings once knew landscapes, now erased from the visible world, is unquestionably true. People walked where fishing boats pass today. Fires burned on ground now buried beneath marine sediments. Children grew up beside rivers whose channels can now only be detected using geophysical instruments. The difference is crucial. The real lost worlds are not necessarily hidden because someone suppressed their history or because a mysterious civilization disappeared without trace. They are hidden because Earth changed. Water moved across the land sediment, accumulated memory fragmented, and time removed the people who knew the old geography firsthand. As underwater archaeology begins to explore these submerged surfaces, scattered traces are emerging. Stone tools drowned forests, ancient riverbeds, and submerged settlements reveal that the continental shelves are not empty spaces between modern nations. They are archives. And in several places those archives preserve something more compelling than an ambiguous ancient map, direct evidence that human worlds once existed where there is now only sea. Once the modern ocean is mentally stripped away from the continental shelves, the planet begins to look unfamiliar. The drowned terrain is not a collection of narrow strips around the edges of continents. In some regions, it forms enormous territories large enough to hold river systems, wetlands, forests, animal populations, migration routes, and human communities for thousands of years. These places are not hypothetical. Their former existence can be reconstructed from seabed topography, sediment, pollen, fossil remains, drowned forests, and the geometry of ancient river channels. The difficulty is not proving that such landscapes existed. The difficulty is understanding what happened there before the sea covered them, because underwater archaeology is still trying to recover a record that dryland archaeology has only rarely had to confront on such a scale. Doggerland remains one of the clearest examples. Beneath the North Sea, researchers have reconstructed a landscape that once connected Britain with continental Europe. It contains former valleys, river channels, wetlands, and higher ground. During colder periods, parts of this region are open steppe or tundra-like environments. Later, as the climate warms, woodland and marsh spread across the land. Mesolithic communities move through these environments, exploiting fish-game plants and seasonal resources. The modern sea hides almost everything, but it occasionally returns fragments. Trawlers working the North Sea have brought up animal bones, antlers, mammoth remains, and prehistoric artifacts from the seabed. Such finds are often accidental, yet together they reveal that the water conceals an archaeological landscape rather than empty geological space. The scale changes the way disappearance should be understood. Doggerland is not destroyed in a single dramatic night. Large areas are gradually lost as sea level rises. Communities have time to move, adapt, and perhaps return to shrinking islands and wetlands. Some generations may notice the coastline retreat only modestly. Across many generations, however, the transformation becomes enormous. Land that grandparents knew becomes inaccessible to grandchildren. Rivers become tidal channels. Familiar travel routes end at newly formed shorelines. Eventually, the surviving high ground itself disappears. This slow drowning is important because popular stories tend to prefer catastrophe. A civilization destroyed by one giant wave is easy to imagine. A landscape transformed over centuries is less dramatic, yet probably more representative of many real prehistoric experiences. Catastrophes still occur within that larger process. The Strega tsunami strikes parts of northern Europe around 8,000 years ago, sending powerful waves into coastal areas already affected by rising seas. It may have caused devastating local destruction, but it does not explain the entire disappearance of Doggerland. The long-term cause is sea level rise. Other submerged landscapes preserve more concentrated traces of settlement. Off the coast of modern Israel lies Atlit Yam, a Neolithic site now several meters below the Mediterranean surface. It dates to roughly the 7th millennium BCE and preserves evidence of houses, wells, burials, and subsistence activity. One of its most striking features is a group of large stones arranged around an ancient freshwater source. Whatever exact social or ritual meaning the arrangement once held, it demonstrates something simple and powerful. People built enduring places on ground that is now underwater. Atlit Yam also shows why coastal archaeology is especially vulnerable. Settlements are often established near freshwater fishing grounds, fertile soil, and access to marine resources. These are precisely the low-lying locations most likely to be inundated as sea level changes. When such sites disappear beneath water, later archaeology inherits a distorted distribution. Inland sites remain visible. Coastal ones vanish. Entire patterns of settlement can therefore appear different from the reality experienced by prehistoric communities. In the eastern Mediterranean, other submerged remains have been discovered near ancient shorelines, though not all belong to the deep prehistoric period. Harbours, quarries, structures, roads, and settlements from later eras illustrate the same principle on smaller timescales. Tectonic movement can lower coastlines. Earthquakes can submerge ports. Local sea level changes can alter shorelines even when global sea level is relatively stable. Human history repeatedly unfolds on a moving boundary between land and water. The Black Sea has generated particularly intense debate. Some researchers have proposed that marine waters entered the basin rapidly during the early Holocene, producing dramatic flooding that might have influenced later flood traditions. Others argue for different sequences, rates, and magnitudes of water level change. The evidence is complex, and scholars still debate the precise nature of the transition. The important lesson is not that a specific biblical or mythological flood has been scientifically confirmed. It has not. The lesson is that prehistoric communities around changing basins could indeed witness significant shoreline transformations. Farther east, the drowned plains of Sunderland present an archaeological challenge on an entirely different scale. During lower sea levels, large areas between the modern islands of Southeast Asia are exposed. River systems cross terrain now beneath the Java Sea and South China Sea. Human populations inhabit the broader region tens of thousands of years before these plains are fully submerged. Yet systematic underwater investigation of such immense tropical seabeds is difficult. Sediment can bury sites deeply. Marine growth obscures surfaces. Trawling and modern development can disturb remains. The absence of spectacular underwater cities is therefore not proof that coastal communities were absent. At the same time, there is no reliable evidence for a highly advanced lost civilization of the type imagined in popular Atlantis-like theories. This distinction matters. Real submerged archaeology can be extraordinary without supporting every claim attached to it. Stone Age communities do not need monumental architecture to be historically important. A cluster of stone tools found in a former river valley can reveal migration patterns. A preserved tree stump can reconstruct ancient vegetation. Shell middens can show diet. Pollen trapped in sediments can reveal environmental change. These small traces are often more informative than a dramatic but ambiguous shape on a map. Along parts of the European coastline, submerged forests provide some of the most haunting evidence. Tree stumps and roots preserved beneath tidal sediments sometimes become visible during unusually low tides or after storms remove sand. They stand where woodland once grew on dry ground. The image is simple enough to require almost no explanation. A person can walk across a beach today and see the remains of trees rooted in a landscape that existed before the sea advanced over it. Such discoveries help explain how rapidly the familiar can become alien. A forest does not move when the sea arrives. It dies, collapses, becomes buried, and eventually disappears beneath sediment. Thousands of years later, storms briefly uncover it. The coastline seems to reveal an older version of itself. Underwater archaeologists are now using increasingly sophisticated methods to locate these buried worlds. High-resolution sonar maps the shape of the seabed. Seismic profiling can reveal sediment layers and buried channels beneath it. Core samples recover pollen shells, organic material, and evidence of ancient soils. Divers investigate promising sites directly. Remotely operated vehicles can reach areas difficult or dangerous for humans. Researchers combine these data with models of past sea level to predict where prehistoric people were most likely to live. One lesser-known challenge is that the most promising ancient surfaces may not be visible on the seafloor at all. Thousands of years of sediment can bury them several meters down. A flat modern seabed may conceal a former river valley beneath layers of mud. Archaeologists, therefore, cannot simply search for ruins sitting openly on the bottom. They have to reconstruct landscapes that are both submerged and buried. This makes the oceans enormous archaeological archives whose pages are difficult to open. The continental shelves contain pieces of human prehistory that may eventually change migration timelines, settlement models, and understanding of coastal adaptation. What they have not yet produced is credible evidence for a forgotten globe-mapping civilization capable of transmitting an Antarctic survey into the hands of Piri race. The contrast is revealing. Popular mystery looks for one spectacular lost world. Archaeology finds many smaller ones. They are less technologically impossible but more human. They contain wells, camps, forests, hearths, tools, animal bones, and riverbanks. They belong to people adapting to changing environments rather than masters of a forgotten global science. And because these landscapes genuinely vanished, they raise a deeper question than the old map alone can answer. When whole coasts disappear and communities move away, how long can the memory of that transformation survive? A parchment can preserve geography through lines, but people without written maps preserve landscapes differently. They carry them in stories, place names, journeys, warnings, and traditions. Some of those memories may fade within generations, others may last far longer than expected. Long before coastlines are fixed in ink, they exist in memory. A community does not need a parchment chart to know the shape of its world. People know where rivers bend, where fresh water appears during dry seasons, where dangerous currents form where animals cross valleys, where storms arrive from the horizon, and which route leads safely between distant settlements. That knowledge can be carried through generations without resembling anything that a modern observer would call a map. It can survive through stories, ceremonies, place names, repeated journeys, landmarks, songs, and practical instructions. When landscapes change, those traditions may change with them, and sometimes buried inside stories that seem legendary. Researchers find details that appear to correspond with environmental events, far older than the written records that eventually preserve them. This possibility creates one of the most fascinating connections between drowned landscapes and ancient geographical memory. If prehistoric people watched coastlines retreat as sea levels rose after the last ice age, they would have experienced transformations that later generations could scarcely imagine. A bay might once have been a valley. An island might once have been a hill connected to the mainland. Fishing grounds might lie above former forests. Communities moving inland could continue telling stories about places their ancestors inhabited beyond the new shore. The difficulty is determining how long such memories can remain recognizable. Oral traditions are not recordings. Every generation inherits a story through human minds rather than fixed text. Details can be simplified, expanded, combined with other events, or adapted to new cultural meanings. A local flood can become universal. A real ancestor can become a legendary figure. A dangerous crossing can become a supernatural boundary. The longer the transmission continues, the more difficult it becomes to separate environmental observation from later symbolism. Yet there are cases that encourage careful attention. Around the Australian coastline, researchers have examined indigenous oral traditions describing rising seas, submerged land, vanished islands, and former coastlines. Some accounts appear consistent with landscapes that would have existed when sea levels were lower thousands of years ago. Scholars have proposed that certain traditions may preserve memories of coastal changes dating back several millennia, potentially far longer than once assumed possible for oral transmission. Such interpretations must be handled cautiously. Matching a story to a reconstructed coastline is not the same as directly dating the story. Oral traditions can incorporate observations made at different periods, and researchers must avoid forcing every flood narrative into a geological event. Still, the possibility is important. Human societies with strong systems of intergenerational teaching can preserve remarkably durable knowledge, especially when that knowledge is tied to specific places and repeated cultural practices. Pacific societies offer another illustration of how geography can exist without conventional maps. Polynesian navigators cross enormous stretches of open ocean, using knowledge encoded through stars, ocean swells, winds, birds, clouds, and the behavior of waves around unseen islands. Their navigational systems demonstrate that sophisticated spatial understanding does not require latitude and longitude written on paper. A trained navigator carries relationships between islands and environmental signals in memory. This matters for the lost world question because modern observers often search for ancient geographic knowledge in the wrong form. They expect a map. Prehistoric people may instead have possessed detailed mental geographies that left almost no archaeological trace. If a coastline disappeared, its memory might survive as narrative rather than drawing. That does not mean oral traditions secretly contain precise global cartography. It means that human geographic knowledge can be durable without becoming an artifact. Flood traditions occur in many cultures, and this has often encouraged claims that they all descend from one enormous prehistoric catastrophe. The evidence does not support such a simple conclusion. Floods are common human experiences. Rivers overflow. Tsunamis strike coasts. Storm surges inundate settlements. Lakes change level. Dams formed by ice or landslides can fail suddenly. Communities living near water repeatedly face destructive flooding, so similar stories can arise independently. Mesopotamia provides a famous example. Ancient texts preserve traditions of catastrophic floods, and archaeology shows that some Mesopotamian cities experienced major local flooding at different times. But evidence for local floods does not establish a single global deluge. River civilizations naturally develop powerful cultural memories around water, because water creates both fertility and danger. The same rivers that sustain cities can destroy them. The Black Sea has generated another attempt to connect geology with inherited flood stories. One hypothesis proposes that rising Mediterranean waters entered the Black Sea basin dramatically, during the early Holocene, rapidly flooding inhabited margins. The scale and speed of this event remain debated, and subsequent research has produced more complicated reconstructions than the most dramatic early versions suggested. It remains possible that changing shorelines affected prehistoric populations, but linking those changes directly to specific later myths is far more difficult. This pattern repeats elsewhere. Geological evidence can establish that a coastline changed. Archaeology can sometimes establish that people lived nearby. Oral traditions may describe a flood or drowned land, but connecting all three requires caution. Similarity is evidence worth investigating, not proof of direct transmission. The same discipline should be applied to ancient maps. A strange coastline on parchment and a real submerged landscape beneath the sea do not automatically belong together. The Piri-Reis map does not become an Ice Age chart merely because Ice Age coastlines existed. A chain of transmission would still need to be demonstrated. There would need to be some reason to identify specific mapped features with specific drowned geography, and the chronology would have to make sense. What survives in the record instead suggests a more complex picture of human memory. Geography can persist in fragments. A sailor copies an older coastline without knowing who first surveyed it. A community preserves a story about land beyond the shore without knowing exactly when it vanished. A place name survives after the landscape that gave it meaning changes. A legend attaches itself to a geological event that occurred centuries earlier. Memory rarely travels through history unchanged, but it does not always disappear completely either. One lesser-known example of long environmental memory comes from volcanic landscapes. Communities living near active volcanoes sometimes preserve traditions describing eruptions that occurred before written records in the region. Researchers can compare those traditions with geological deposits, though the connections are often uncertain. The important point is that dangerous landscape events are culturally memorable. A coastline steadily disappearing over generations could be equally significant. There is also a practical reason for preserving such information. Stories about past disasters can function as warnings. A tale describing water reaching a particular hill, a shoreline suddenly retreating before a wave, or an area that should not be settled, may contain survival knowledge even after its historical origin becomes obscure. Cultural memory does not have to preserve exact dates to remain useful. For prehistoric coastal communities, the advancing sea may have created generations of such knowledge. People could remember that ancestors once crossed a plain now divided by water. They could know that stone structures or forests existed beneath shallow bays. During unusually low tides, remnants of older landscapes might even become visible, reinforcing stories about drowned land. Over centuries, those memories could acquire supernatural meaning. A submerged settlement becomes a city punished by the gods. A vanished island becomes the homeland of ancestors. A tsunami becomes a battle between supernatural beings. The factual core, if one exists, becomes almost impossible to isolate from the cultural structure surrounding it. This is why legends of Atlantis and other drowned worlds are so tempting to connect with post-Ice Age sea level rise. Plato's Atlantis story describes an island power destroyed and submerged, but there is no mainstream archaeological evidence establishing Atlantis as a historical Ice Age civilization. Many attempts have been made to locate it in the Mediterranean Atlantic and elsewhere, yet no proposed identification has gained scholarly consensus. The story remains culturally powerful, but power is not proof. The more defensible conclusion is also more interesting. Humanity has repeatedly experienced the loss of land to water. Some memories of those losses may have survived for surprisingly long periods. Ancient stories can sometimes preserve environmental information, but they must be evaluated individually rather than assembled into a single global catastrophe narrative. The Piri-Reis map belongs to another form of inherited memory. Its coastlines travel through documents rather than oral tradition, yet the underlying process is strangely similar. Information passes from generation to generation. Origins become uncertain. Details change. Some parts remain accurate while others become distorted. Eventually, later people inherit a fragment and try to reconstruct what its makers once knew. That process leaves behind a dangerous illusion. When an old map contains a shape that resembles something familiar, It is easy to assume the resemblance must represent preserved ancient knowledge. But maps, like stories, can change during transmission. They can accumulate errors, merge unrelated traditions, and create patterns their makers never intended. The next layer of the mystery, therefore, lies not beneath the sea, but inside the human tendency to turn imperfect lines into recognizable worlds. A coastline does not need to be accurate to become convincing. It only needs to contain enough familiar shapes for the mind to begin completing the pattern. Once a viewer decides that an old map might show a particular continent, every cape and bay becomes potentially significant. A curve begins to resemble a modern peninsula. An irregular projection becomes an island. A distorted shoreline becomes evidence of an unusual projection, rather than evidence that the identification itself may be wrong. This is one of the most persistent traps in interpreting historical maps, because the human brain is exceptionally skilled at finding recognizable structures inside incomplete information. The same ability that allows people to identify a familiar face in poor light can also turn ambiguous cartography into apparent evidence of a lost world. The problem becomes especially severe when old maps are compared directly with modern ones. Modern coastlines are measured with satellites, global positioning systems, aerial surveys, and enormous databases of geographic coordinates. Historical charts were produced under completely different conditions. Even a skilled 16th century navigator works with uncertain distances, imperfect instruments, magnetic bearings, estimated speed, and observations taken from a moving ship. Putting the two maps side by side can therefore create a misleading test. The old chart is judged according to a level of geometric precision it was never designed to achieve. Longitude is central to the problem. Latitude can be estimated by observing the altitude of the sun or particular stars, though clouds' instrument quality and calculation errors still matter. Longitude at sea is much more difficult. Determining it accurately requires knowing the time difference between a reference location and the ship's current position. Before reliable marine chronometers, this is extremely challenging. Navigators rely heavily on dead reckoning, estimating their movement from direction, speed, currents, and elapsed time. Small errors accumulate over long voyages. Imagine a vessel sailing along an unfamiliar coast for several weeks. Its latitude observations are reasonably good, but its estimate of east-west movement gradually drifts. The captain records bays, river mouths, capes, and islands correctly in sequence, while placing the entire coastline too far east or west. A later cartographer inherits this chart and combines it with another survey, whose errors run in a different direction. The local geography may remain recognizable, but the continental outline becomes stretched or compressed. This helps explain a feature that can seem paradoxical in early maps: detailed coastlines attached to badly shaped continents. There is no contradiction. A sailor can accurately observe the order of coastal landmarks without knowing their precise global coordinates. When those observations are assembled across thousands of kilometers, the accumulated positional error becomes obvious. Magnetic variation introduces another complication. A compass does not always point toward geographic north. The difference between magnetic and true north varies by location and changes over time. Early navigators understand aspects of this problem but cannot model it with modern precision. Bearings copied from different regions can therefore introduce subtle rotations when combined. Then there is the map projection itself. No flat map can reproduce the spherical Earth without distortion. Modern cartographers choose mathematical projections depending on what they want to preserve: direction, area, distance, shape, or some compromise among them. Early mapmakers may use methods that are only partly mathematical, or combine material produced according to different conventions. When modern researchers attempt to reverse engineer a single projection from such a composite map, they can accidentally impose consistency where none originally existed. The Peary Race map is particularly vulnerable to this treatment because it is assembled from multiple sources. If one source covers Western Africa, another the Caribbean, another Brazil, and another portions of the Atlantic, those charts may not share one scale or one coordinate framework. Peary Race has to make them coexist on one piece of parchment. The result may contain seams that are no longer obvious, because the final coastlines are drawn continuously. A useful analogy is a mosaic assembled from photographs taken with different lenses. Each photograph may accurately show its own subject. But if the images are enlarged, rotated, and joined without correcting their perspectives, the final panorama can contain warped buildings and bent horizons. Someone centuries later who assumes the panorama was produced from one camera position may invent complicated explanations for distortions that actually came from combining separate images. Copying adds still more uncertainty. A coastline traced by hand can shift slightly. The next copy introduces another change. A mapmaker may simplify small bays because the scale is too small to include them. Decorative elements can interfere with geography. Labels occupy space and may force lines to move. Damage to the source can require reconstruction. None of these changes needs to be large individually. Over several generations, they can produce substantial differences. One surprisingly persistent cartographic phenomenon is the phantom island. For centuries, maps include islands that do not exist. Some originate from navigation errors. Others may be real islands placed twice because different names are mistaken for different locations. Some arise from mirages, clouds, floating ice, or misidentified coastlines. Once printed on respected maps, they become difficult to eliminate. Sailors sometimes search repeatedly for islands that exist only because previous mapmakers copied them. The story of Hy Brasil illustrates how legend and cartography can reinforce each other. An island under versions of that name appears west of Ireland on maps for centuries, changing position and shape over time before eventually disappearing from serious cartography. Its persistence does not demonstrate that a large island recently sank beneath the Atlantic. It demonstrates how geographic expectations can survive through copying even without reliable confirmation. Similar processes affect imagined southern continents. For centuries, cartographers depict a great southern landmass because classical geographic reasoning and assumptions about global balance encourage them to expect one. As exploration expands, this hypothetical continent changes shape. Pieces shrink, move, or separate. Eventually, Australia and Antarctica emerge as real geographic entities, but earlier southern land masses cannot simply be treated as accurate maps of those later discoveries. This is important for interpreting the Peary Race coastline. A map can contain real South American information and speculative southern geography simultaneously. It can preserve good observations beside inherited expectations. The existence of one accurate region does not guarantee that every neighboring line represents direct observation. Modern digital techniques can make the problem worse if used carelessly. An old map can be scanned, rotated, stretched, warped, and overlaid on a modern projection. If enough transformations are allowed, apparently impressive matches can emerge. But every adjustment adds freedom. A valid comparison should explain why those transformations are historically justified, rather than simply selecting the arrangement that looks best. Scholars therefore examine contextual clues alongside geometry. Place names matter, annotations matter. The sequence of geographic features matters. Other contemporary maps matter. The known voyages available to the mapmaker matter. When these forms of evidence converge, an identification becomes stronger. When only visual resemblance supports it, caution is necessary. Applied to Piri Reis, this broader evidence favours the interpretation that the southern coastline belongs to the developing European picture of South America, rather than to Antarctica. The coastline is distorted, but distortion is expected. Its unusual eastward turn may reflect limited parchment space, uncertain longitude, composite source material, or attempts to represent a coast whose southern extent remained unknown. Scholars still debate details of the construction, but none of these uncertainties requires knowledge of a hidden polar continent. There is a deeper irony in this. The map becomes famous because its errors are treated as evidence of impossible accuracy. If the southern coast looked exactly like a recognizable 16th century South America, there would be little mystery. It is precisely because the geography is imperfect that later viewers can reinterpret it. Yet imperfections are also clues. They preserve traces of the process by which knowledge was assembled. A stretched coastline can reveal navigational uncertainty. A duplicated island can expose overlapping sources. A strange orientation can show where separate mapping traditions were joined. Instead of asking only what modern land mass a shape resembles, historians can ask what sequence of decisions produced that shape. Seen this way, the Piri Reis map becomes less like a coded message and more like an archaeological site made of information. Its layers are not soil and stone, but observation, copying, measurement, expectation, and error. Each distortion records something about the limits of knowledge in 1513, and those limits matter because a truly extraordinary ancient map would have to behave differently. If a lost civilization had surveyed unknown continents with advanced geographic precision, traces of that ability should appear consistently rather than only where ambiguous shapes permit interpretation. There should be patterns difficult to explain through ordinary cartography. There should be evidence beyond resemblance. That raises the hardest question in the entire mystery: what would scientists and historians actually need to find before an ancient map could overturn the accepted story of human exploration? Before reaching that test, however, the search must leave the parchment again and descend into the environments where genuine lost landscapes are being recovered, because modern archaeology now possesses tools capable of finding worlds that earlier generations could only imagine. The search for lost landscapes has changed dramatically because archaeologists no longer have to wait for the sea to give something back by accident. For much of the 20th century, underwater prehistory remains a difficult frontier. Divers can investigate known wrecks, harbours, and submerged structures, but vast prehistoric landscapes beneath shallow seas are harder to locate. They may contain no walls, no statues, and no obvious monumental ruins. Their archaeological traces can be small, scattered and buried under meters of sediment. Today, however, researchers increasingly approach the seabed as they would a hidden landscape on land, reconstructing ancient rivers, valleys, terraces, shorelines, and ecological zones before deciding where people were most likely to have lived. This shift is crucial because human beings rarely choose settlement locations randomly. Freshwater matters. Sheltered bays matter. River mouths, estuaries, marshes, elevated ground, and predictable food resources matter. If archaeologists can reconstruct where these features existed when sea level was lower, they can narrow the search dramatically. Instead of looking across an entire continental shelf, they can identify former environments that would have been attractive to prehistoric communities. High-resolution sonar is one of the key tools. Survey vessels send sound waves toward the seabed and measure the returning signals, building detailed models of underwater topography. Subtle channels, ridges, terraces, and depressions can emerge from what otherwise appears to be featureless water. Some of these forms are modern, others are remnants of landscapes shaped when the area was dry land. A broad depression may represent an ancient river valley. A buried ridge may once have overlooked a floodplain. A series of terraces may mark former shorelines. Seismic profiling allows researchers to look beneath the seabed itself. Sound energy penetrates layers of sediment and reflects from boundaries between different materials. The resulting images can reveal buried channels, ancient soil surfaces and layers deposited during changing environmental conditions. This matters because the most interesting prehistoric ground may lie several meters below the modern seabed. Thousands of years of marine sediment can conceal the surface on which people once walked. Core samples then recover physical evidence from those buried layers. Pollen can reveal what plants once grew nearby. Microscopic organisms can indicate whether an environment was freshwater, brackish, or marine. Shells can be dated. Peat can show that marshes once existed where open sea is found today. Charcoal may indicate burning, though determining whether fire was natural or human-made requires caution. Sediment chemistry can preserve other signs of environmental change. When archaeological materials appear, the evidence becomes more direct. Stone tools can survive underwater for immense periods, especially when rapidly buried. Wooden objects are much less likely to survive unless oxygen-poor sediments protect them from decay. Bone preservation varies greatly depending on local conditions. A submerged prehistoric site can therefore look very different from a land site excavated in dry soil. The record is selective from the beginning. This is why absence is difficult to interpret. If sonar finds no buildings, it does not mean no people lived there. Many prehistoric communities built with wood reeds, hide, or other materials that disappear. A small seasonal camp may leave only a thin scatter of stone flakes and hearth debris. Even a substantial settlement can become difficult to recognize after thousands of years of erosion, sedimentation storms, and marine activity. The waters around northern Europe have become a major laboratory for this kind of reconstruction. Energy development, commercial, geophysical surveys, and scientific projects have produced enormous quantities of seabed data from the North Sea. Researchers can use some of these data sets to map former drainage systems across Doggerland. Ancient river channels appear beneath modern sediments like ghost rivers still tracing the shape of a vanished country. These reconstructions reveal that the drowned plain was not uniform. It contained ecological zones that would have offered very different opportunities for human settlement. A lesser-known aspect of this work is how much archaeology can benefit from industries that are not archaeological at all. Oil and gas exploration, offshore wind development, submarine cable installation, and marine engineering all required detailed knowledge of seabed conditions. Geophysical surveys collected for commercial purposes can sometimes reveal ancient landscapes. Archaeologists then reinterpret information originally gathered for entirely different reasons. This creates an unexpected collision between the modern economy and deep prehistory. A survey intended to determine where an offshore structure can safely be built may uncover a buried river system last seen by humans thousands of years ago. Development can threaten archaeological material, but it can also generate data that would otherwise be too expensive for researchers to collect independently. Underwater investigation is expanding beyond Europe as well. Along continental shelves in Asia, the Middle East, Australia, and the Americas, researchers are increasingly interested in areas exposed during periods of lower sea level. The archaeological stakes are enormous because many major questions about human migration involve coastlines that no longer exist. One influential model of early human dispersal proposes that coastal environments may have played an important role as Homo sapiens expanded into new regions. Shellfish, fish, sea mammals, birds, and coastal plants can provide dependable resources. Shorelines can also function as travel corridors. Yet testing this idea is difficult because many relevant Pleistocene coasts are underwater. Archaeologists may be searching for evidence of coastal migration on landscapes that have physically disappeared. The same problem affects debates about the initial peopling of the Americas. During lower sea levels, the Pacific coast of North America looked very different from today. If some early populations travelled along that coastline, many of their sites may now lie submerged. This does not prove any particular migration route by itself, but it explains why the terrestrial archaeological record may be incomplete. Researchers are therefore developing predictive models. They combine reconstructions of ancient sea level with topography, freshwater sources, ecological productivity, and known archaeological behaviour. These models identify areas where early sites are most likely to occur. Remote sensing can then survey those locations more efficiently. The process is slow. Underwater work is expensive. Weather restricts access. Visibility can be poor. Sediment can obscure artifacts. Potential sites may cover huge areas. Even when objects are found, their context must be established carefully. A stone tool lying on the seabed today may have been moved by currents, fishing activity, or erosion. Archaeologists need to determine whether material remains close to where prehistoric people originally left it. This emphasis on context distinguishes scientific archaeology from treasure hunting. A dramatic artifact without its surrounding deposits can tell less than an ordinary object recovered from a well-dated layer. A hand axe is interesting. A hand axe found within a preserved ancient land surface alongside environmental evidence can reconstruct behavior, climate, and chronology. The same principle applies to old maps. Context determines meaning. A mysterious coastline is far more convincing if it connects with independent evidence from archaeology, geology, and historical transmission. Without that support, resemblance remains weak. Modern underwater archaeology has already proven that lost human landscapes are real. It has found submerged settlements, tools, drowned forests, former river systems, and ancient coastlines. But the pattern emerging from these discoveries is not one of a single vanished global civilization. It is a mosaic of many communities occupying many different environments. Some are hunter-gatherers, some are early farmers, some build villages, some move seasonally. Their technologies fit the periods in which they lived. This is important because genuine discoveries establish a baseline for what lost worlds actually leave behind. Even modest communities produce material traces. Stone flakes, food, remains, hearths, post holes, burials, tools, and environmental changes can survive. Large societies produce even more buildings, roads, mines, workshops, harbours, waste deposits, agricultural systems, and networks of exchange materials. A civilization capable of mapping the planet should therefore leave a correspondingly significant archaeological footprint somewhere. It might vanish politically. Its language might disappear. Its cities could erode or become submerged. But total absence across every category of evidence would be extraordinary. The ocean does hide enormous parts of the human past, and future discoveries may alter important parts of prehistory. That possibility should remain open. Yet scientific openness does not mean treating every imagined civilization as equally probable. New claims must meet the evidence already known, and this is where the old map faces its most demanding test. It is not enough for one coastline to look unusual. If it truly points toward a forgotten world of advanced ancient navigation, then archaeology should eventually uncover traces consistent with that achievement. The question is no longer whether lost worlds existed. They did. The question is what kind of evidence would be powerful enough to prove that one of them possessed knowledge far beyond anything currently known from its time. If a discovery were ever to overturn the accepted history of ancient navigation, it would not be rejected simply because it was surprising. Archaeology has already absorbed discoveries that once seemed improbable. Human arrival dates have been pushed backward. Previously unknown cultures have emerged from deserts and forests. Settlements once considered too early have forced researchers to reconsider how quickly complex societies developed. Ancient DNA has revealed populations and migrations that left little obvious trace in later historical records. The past is not protected from revision, but revision requires evidence strong enough to survive the possibility of error, coincidence, contamination, mistaken dating, and wishful interpretation. For the Piri race mystery, that distinction is everything. Suppose an ancient map were discovered in a securely dated archaeological context several thousand years older than known global cartography. The first task would be to establish that the object itself is genuine. Its material would need to be dated. Ink or pigment would need chemical analysis. The archaeological layer containing it would have to be undisturbed. Researchers would examine whether the object could have entered an older deposit at a later time. Independent laboratories would ideally confirm important results. Extraordinary claims become stronger when several methods converge rather than depending on a single test. The map would then need to contain geography that could not reasonably have been known in its period. A vague southern landmass wouldn't be enough. Ancient mapmakers imagined unknown lands, and accidental resemblance is common. The geography would need a consistent pattern of recognizable features, coastlines, islands, rivers, mountain systems, or distances corresponding to a real region beyond known travel networks. Those features would have to match under a coherent mapping system, rather than through repeated rotation and selective stretching. Accuracy across the whole object would matter. If a supposed prehistoric map showed one section of Antarctica convincingly, but misplaced every surrounding feature, the identification would remain doubtful. A genuine survey should contain relationships between places. Distances should make sense relative to one another. Geographic errors might still exist, but they should follow understandable patterns. A map cannot be declared astonishingly precise by focusing only on its stronger similarities and ignoring its failures. Even such a map would represent only the beginning. Archaeologists would ask who created it. A society capable of long-distance surveying should leave traces of the technologies and institutions required to support that activity. Ships have to be built and maintained. Crews have to be fed. Navigation knowledge has to be taught. Long voyages require planning, storage, repair, and repeated access to ports or landing places. Map production requires some system for recording and transmitting spatial information. Not every component must survive. Wooden ships decay. Coastal settlements can drown. Organic records disappear. But complex activity usually produces many different categories of evidence, and it is unlikely that every category vanishes everywhere. Stone anchors may remain. Harbour works may survive. Imported materials may reveal long-distance exchange. Distinctive tools can travel between regions. Human remains can preserve genetic evidence of migration. Isotopic analysis can reveal individuals who grew up far from where they were buried. Even parasites and domesticated species can move along human travel networks. This is why archaeology becomes more powerful when independent evidence converges. A strange artifact alone can be misunderstood. A strange artifact found alongside foreign materials, genetic connections, harbour installations, navigation tools, and matching evidence at distant sites becomes much harder to dismiss. The strongest historical revisions are built from networks of clues. Consider what would be expected from a civilization capable of systematically mapping Antarctica. Reaching the continent itself would require extraordinary maritime endurance, particularly if voyages occurred under climatic conditions resembling those of the human era. Repeated surveying would demand more than one accidental landfall. Mariners would need to travel along extensive coastlines, determine relative positions, and somehow transmit the resulting information home. If the proposed map represented an ice-free coastline from a much earlier geological period, the chronological problem would become vastly greater, because humans did not exist during the relevant deep time conditions. A civilization performing such work should therefore transform more than cartography. Its maritime technology would likely affect trade, migration, warfare, resource distribution, and cultural contact across other parts of the world. Those effects should leave archaeological patterns. Yet no securely dated prehistoric evidence demonstrates a global seafaring society operating at that level. This does not mean ancient navigation was primitive. The archaeological record repeatedly shows that early humans crossed water earlier than older historical models once assumed. The settlement of Sahul required sea crossings tens of thousands of years ago. Mediterranean islands were visited or settled in prehistoric periods. Later Austronesian expansion demonstrates extraordinary open ocean navigation. These achievements are supported by combinations of archaeology, linguistics, genetics, environmental evidence, and comparative technology. Their reality provides an important lesson. Ancient maritime accomplishments do not need mysterious maps to be recognized. When sufficient evidence exists, mainstream history changes. The same is true for vanished civilizations. The Maya were never completely forgotten by local populations, but many of their cities became obscured by tropical forest before modern archaeological investigation revealed their scale. Angkor's landscape has been transformed by remote sensing, which exposed extensive networks of roads, reservoirs, canals, and settlement features beneath vegetation. In the Amazon Lleida, an archaeological research have revealed large earthworks and settlement systems that challenge older assumptions about population and landscape modification. None of these discoveries required rejecting scientific standards. Better evidence produced a better history. One lesser-known point is that dramatic archaeological revisions often begin with ordinary-looking data. A pattern in soil chemistry, a cluster of post holes pollen changes, or subtle lidar features can ultimately reveal large human systems. Evidence does not need to look spectacular to be revolutionary. It needs to be reliable. This is precisely where claims about lost mapping civilizations remain weak. The proposed evidence is often visually spectacular but contextually isolated. An ambiguous coastline is interpreted as Antarctica. A myth is interpreted as a record of global catastrophe. A submerged geological formation is interpreted as architecture. Each clue is then used to support the others, even though none has been independently established. The argument becomes circular. The map proves the civilization, and the assumed civilization explains the map. A stronger approach reverses that process. Each piece of evidence must stand on its own before connections are made. If an underwater structure is claimed to be artificial geology, and archaeology must establish that independently. If a map is claimed to show an unknown continent, cartographic analysis must establish the identification independently. If a civilization is proposed, datable artifacts and settlement evidence must establish its existence independently. Only then can the pieces legitimately reinforce one another. For the Piri Reis map, this standard leaves a fascinating artifact but not proof of a forgotten global civilization. Its known historical context fits the early 16th century. Its sources fit a world of Portuguese, Spanish, Mediterranean, Arabic, and classical geographic information. Its distortions fit the difficulties of combining those traditions. Its supposed Antarctic coastline does not provide enough consistent geographic evidence to overturn that explanation. Still, the conclusion should not be that everything important about the map is solved. Some of its exact sources remain unidentified. The route by which particular geographic details reached Piri Reis may never be reconstructed. Much of the original map is missing. Many charts circulating in his world have disappeared completely. Scholars still debate specific details because historical evidence rarely survives in perfect condition. That uncertainty is legitimate. It is different from using uncertainty as evidence for whatever explanation seems most exciting. A gap in knowledge is a gap, not automatically a doorway to a lost civilization. Future discoveries could change the picture. A previously unknown Portuguese chart might reveal exactly how the southern coastline developed. An Ottoman archive could preserve another copy or related map. Underwater archaeology might uncover prehistoric coastal societies more extensive than currently known. Any of these discoveries could force historians to revise parts of the story. But the greatest possibility is not that archaeology will confirm a legend exactly as imagined. History usually surprises in less predictable ways. The worlds being recovered beneath forests, deserts, cities, ice and oceans rarely resemble the myths created before their discovery. They are stranger in their details because they were real. The ancient map therefore remains suspended between what is known and what is missing. It does not prove the impossible, yet it reminds us that enormous portions of human knowledge have vanished. To understand its real lost world, the search must return to those missing records, drowned coastlines, and forgotten chains of transmission, not to find Atlantis hiding behind the parchment, but to recognize how much of the ordinary human past can disappear without leaving a complete map behind. The lost world behind the map is beginning to look very different from the one imagined in the most dramatic theories. There is no secure evidence of an Ice Age civilization sailing around Antarctica, with instruments centuries or millennia ahead of its time. There is no demonstrated chain carrying a prehistoric global survey through antiquity and into the hands of Piri Reis. Yet something has unquestionably been lost. In fact, several things have disappeared at once: source charts, navigational observations, coastal landscapes, settlements, oral memories, and entire networks through which geographic knowledge once moved. The mystery survives, but its center shifts away from a single impossible civilization and toward the enormous amount of ordinary human experience that history fails to preserve. Consider the missing maps first. Piri Reis explicitly works from earlier material, and most of that material can no longer be inspected. This alone creates a vanished cartographic world. Early Portuguese and Spanish exploration generates charts whose political and commercial value encourages secrecy. Mediterranean sailors possess practical geographic knowledge that may never enter formal books. Maps are captured in war, carried aboard ships damaged by salt water, destroyed by fire, or replaced when they become obsolete. Even important documents can disappear without leaving a trace. The survival of the 1513 fragment is itself almost accidental. It eventually comes to scholarly attention in the 20th century, after being found in Istanbul's Topkapi Palace during work involving the palace collections. Only part of the original world map remains. The missing portion may once have clarified features that now seem isolated or confusing. Perhaps it contained geographic relationships that would make the surviving southern coastline easier to interpret. Perhaps it would create new mysteries instead. There is no way to know unless another fragment someday appears. This is an uncomfortable reality in historical research. The evidence available today is not a carefully selected sample designed to answer modern questions. It is what happened to survive. A fire can remove an archive, a shipwreck can erase a navigator's observations, parchment can be scraped and reused, Paper decays, political regimes destroy records, libraries scatter during wars, historians reconstruct enormous processes from fragments whose survival may depend on chance. The same selective destruction operates archaeologically. Stone monuments attract attention because they endure. Wooden villages vanish more easily. Dry caves preserve organic material that disappears in humid forests. Desert settlements can remain visible while coastal settlements drown. A culture that builds in stone may appear more substantial in the archaeological record than another society with comparable social complexity that relies on perishable materials. This creates a past weighted toward what survives rather than necessarily toward what mattered most to the people living in it. Coastlines intensify that distortion. During the late Pleistocene and early Holocene rising seas remove large areas that may have been particularly attractive to human communities. Modern archaeology therefore begins with a map already missing many ancient coastal zones. Doggerland lies beneath the North Sea. Large parts of Sunderland lie beneath Southeast Asian waters. Former landscapes occupy the Persian Gulf basin and continental shelves around the world. These are genuine lost countries in the geographical sense, though their inhabitants probably would not have understood them as single political territories. No map from those communities is known, but absence of a map does not imply absence of geographic knowledge. People living on changing coastlines know their environments intimately. They know freshwater sources, seasonal routes, dangerous channels, productive fishing areas, and the location of neighbouring groups. Much of this information dies with the cultural systems that carry it. Archaeology may recover a stone tool from the seabed, but it cannot easily recover the mental map once carried by the person who used it. That is perhaps the deepest lost geography of all. Human beings have possessed countless maps that were never drawn. A hunter moving across a Pleistocene plain knows landmarks that no longer exist. A navigator remembers the sequence of islands along a route whose names have changed or disappeared. A family knows where fresh water emerges near a coast later submerged by rising seas. Generations later, fragments of this knowledge may survive as stories. Thousands of years later, even the stories may be gone. Against this background, the appeal of the Piri Reis mystery becomes understandable. The parchment appears to offer something archaeology rarely provides: a visible line connecting the present to lost geographical knowledge. If one strange coastline could be proven ancient enough, perhaps it would rescue an entire forgotten world from silence. The desire behind the theory is almost as interesting as the theory itself. People want the map to remember what history has forgotten, but maps do not preserve memory perfectly. They compress it. They select some features and omit others. They combine observation with convention. They can carry errors for generations. Even modern maps are constructed representations rather than neutral copies of reality. The Piri Reis map is especially layered because it combines information gathered by different people under different circumstances. What survives in the record suggests that its greatest historical value lies precisely in this mixture. The map captures the world during a moment when geographic knowledge is being violently reorganized. Classical ideas remain influential. Mediterranean chart traditions remain active. Portuguese voyages have opened routes around Africa. Columbus and those who follow him have forced Europeans to confront lands across the Atlantic. South America is becoming visible on maps while its full shape remains uncertain. The old geography and the new geography coexist on the same parchment. That coexistence explains why the map can look both remarkably informed and strangely wrong. It belongs to a transitional world. It is not a modern map created too early. It is an early 16th century map doing exactly what such maps often do: combining inherited knowledge with new reports before all the contradictions have been resolved. There is something more compelling in that reality than in the idea of a flawless prehistoric source. Piri Reis is working at the edge of knowledge. He has fragments from people who have crossed seas he has not crossed. Some information may have travelled through captured ships. Some may come from maps whose makers are unknown to him. He has to decide which lines to trust. Every coastline is partly an argument about what the world looks like. Centuries later, viewers make the same kind of decision. They look at the southern edge and decide what they believe it represents. Antarctica transforms the map into evidence of impossible antiquity. South America transforms it into evidence of cartographic distortion. The physical ink does not change. Interpretation does. The mainstream explanation remains stronger because it fits the historical context without requiring a civilization for which independent evidence is absent. But accepting that explanation does not close every question. Historians may never identify all the charts used in 1513. They may never know precisely why a particular coastline was bent in a particular direction. The surviving fragment may always contain unresolved details. That is not a failure. Historical knowledge often ends with probabilities rather than perfect answers. The evidence can strongly favour one explanation while leaving smaller uncertainties intact. Meanwhile, the search for genuine lost worlds continues in places the map never needed to describe. Archaeologists investigate submerged prehistoric coasts. Remote sensing reveals settlement networks beneath forests. Ancient DNA recovers populations invisible in written history. Sediment cores reconstruct environments that vanished before the first chronicles were written. Each method adds another fragment to a global map of human experience that will never be complete. The irony is that the real story becomes larger as the extraordinary claim becomes smaller. The Piri Reis map probably does not reveal Antarctica before its discovery, but it points towards something historically profound. Knowledge is fragile. Landscapes are temporary. Archives disappear. Coastlines move. Entire human environments can vanish so thoroughly that later generations struggle even to imagine them. The parchment has survived for more than 5 centuries, but the information behind it reaches into a much wider sea of lost material. Every visible line may be the final survivor of observations once copied onto documents that no longer exist. Behind those documents stand sailors whose names are forgotten. Behind those sailors stand coastlines that have themselves changed. By the time the map reaches the modern world, it is therefore already a kind of ruin. Not a ruin of a technologically impossible civilization, but a ruin of accumulated knowledge. Its blank spaces and distortions are as important as its accurate coastlines. They show where memory fails, where information collides, and where certainty dissolves. And as the story returns to that southern edge one final time, the question is no longer whether the parchment secretly proves that history is wrong. The more haunting question is how many worlds can disappear before history even has the chance to draw them. The southern coastline still bends across the parchment, exactly as it did when the map first survived into modern view. Nothing in the ink has changed. What changes is the world brought to it. Once Antarctica is discovered, once its hidden bedrock is mapped, once drowned, Ice Age landscapes become part of scientific reconstruction, the old lines begin to collect meanings that their maker could never have anticipated. A coastline becomes a possible continent. A distortion becomes a clue. A missing source becomes a civilization. The map turns into a screen onto which later generations project their own discoveries, fears, and hopes about the past. Yet when the surrounding evidence is restored, a quieter and more convincing interpretation emerges. The map is not valuable because it breaks history. It is valuable because it shows how history is built from fragments, Piri Reis stands near the threshold between two geographic worlds. Behind him lie centuries of Mediterranean navigation, classical geography, Arabic scholarship, Portolan traditions, inherited place names, and practical coastal knowledge accumulated by people whose identities are mostly gone. Around him, Portuguese and Spanish voyages are rapidly transforming the Atlantic into a mapped space. Ahead lies an age when global cartography will become increasingly systematic, mathematical, and standardized. His surviving map belongs to the unstable middle, when new coastlines arrive faster than old assumptions disappear. That instability remains visible in the parchment. Some regions are surprisingly informative, others as distorted. Different scales and source traditions seem to coexist. The southern shore that later attracts so much speculation is exactly where certainty is weakest. Mainstream historical analysis therefore treats it not as a miraculous Antarctic survey, but as part of the imperfect early 16th century attempt to represent South America and the poorly known southern Atlantic. The interpretation is less dramatic, but it fits the evidence more naturally. Still, the phrase Lost World does not have to disappear from the story. It simply needs to be redirected toward the worlds that archaeology and geology can actually demonstrate. There was a lost world beneath the North Sea. Rivers crossed Doggerland where waves now move above buried sediment. There were lost plains across Sunderland joining islands that today seem permanently separated. There were exposed landscapes across the Persian Gulf basin and around continental shelves worldwide. People walked through places that modern maps colour blue. They hunted animals, collected plants, followed rivers, watched weather, crossed wetlands, and built lives on ground later erased from ordinary human sight. Those landscapes do not survive on recognisable prehistoric maps. Their outlines are reconstructed from seabed data, sediment cores, fossils, ancient soils, and models of past sea level. Their human inhabitants survive through scattered artifacts, environmental traces, genetics, and the occasional submerged site. It is slower evidence than a dramatic parchment, but it is stronger because each piece can be tested against the others. The deeper lesson is that civilization does not need to vanish completely for its world to be lost. Geography itself can disappear. A village can survive in memory while the coastline around it changes. A route can lose meaning when a river moves. A harbour can become dry land. A plain can become seabed. A city can remain standing while the network that once gave it importance collapses. Human history is full of places that survive physically but lose their worlds, and worlds that vanish physically while fragments of their memory persist. Maps sit uneasily between these two forms of disappearance. They look permanent because their lines remain fixed, but they often preserve temporary states. Every coastline is a snapshot. Every border is provisional. Every place name belongs to a particular human moment. Even the most accurate modern map will one day describe landscapes that no longer exist exactly as drawn. This makes the Piri Reis fragment strangely appropriate as a symbol. It survives incomplete. Its missing half is as significant as the part preserved. The documents behind it are mostly lost. The navigators who contributed observations are largely anonymous. Some of the coastlines it shows have since been measured with astonishing precision, while others remain reminders of a time when the shape of the world was still being assembled. Scholars may continue debating specific details. New archival discoveries could clarify which source charts Piri Reis used. Better digital reconstruction may explain some distortions more convincingly. Underwater archaeology may uncover settlements on drowned landscapes that transform understanding of prehistoric coastal life. Ancient DNA may reveal migrations no existing map records. The evidence remains incomplete, and that incompleteness is not likely to disappear. But uncertainty should not be confused with emptiness. Enough survives to distinguish between possibility and probability. There is no persuasive evidence that the map records an ice-free Antarctica or preserves the work of an unknown advanced prehistoric civilization. There is abundant evidence that early modern cartography inherited older information through complicated chains, that mapmakers sometimes distorted geography while combining sources, and that enormous inhabited landscapes have genuinely vanished beneath rising seas. The real mystery is therefore not smaller than the legend, it is broader. It concerns the fragility of information itself. Human beings continually produce knowledge and continually lose it. Archives burn, languages die, coastlines shift, memories fade, maps are copied without their sources, settlements disappear beneath water. A person can live inside a landscape that seems permanent and never suspect that on geological timescales it is temporary. The old parchment captures that fragility perfectly. Its ink preserves certainty where the history behind the ink is uncertain. It gives fixed outlines to a world still being discovered. It carries traces of maps that no longer exist, created from voyages, whose details are lost, copied from observations made by people whose names may never be recovered. And somewhere beneath the modern seas lie the reverse of that conditioned landscapes that once existed with absolute physical reality but left no surviving map at all. Those drowned plains may be the most important counterpoint to the famous southern coastline. The map appears to point toward a lost world because modern viewers search its ambiguous lines for one. Archaeology discovers lost worlds by finding the ground itself. A stone tool buried beneath marine sediment does not need interpretation as Antarctica. A drowned forest does not need a secret civilization. A prehistoric well beneath the Mediterranean does not need a forgotten global atlas. These things are direct reminders that human worlds can disappear while history continues above them. The final image is therefore not of a hidden continent waiting to be proven on parchment. It is of two surfaces separated by time, an old map lying beneath glass, and an ancient landscape lying beneath water. One preserves lines without the full story behind them. The other preserves the story's physical ground without the lines that once might have described it. Between them lies the uncertainty that defines so much of the deep human past. The map rests quietly now, no longer needing to prove the existence of an impossible civilization. Its mystery remains, but it has changed shape. The strange coastlines no longer seem like doors that must open onto a forbidden history. They become traces of a world in motion created by people trying to understand distances larger than any one life could travel. Beyond the parchment, the real continents continue changing. Ice presses down on stone, rivers alter course, sediment buries old surfaces, shores advance and retreat. Beneath shallow seas, ancient valleys remain where people once walked beneath open sky. Their footsteps are gone, but the land remembers their world in layers of mud, peat, shell, stone, and buried channels. Perhaps that is why old maps remain so powerful. They offer the illusion that the past can be held still. A coastline becomes a line, a vanished journey becomes a mark, a forgotten place receives a name. For a moment the world seems fixed, but it never was. Every civilization lives inside temporary geography. Every map describes a landscape already changing. Every generation inherits knowledge with pieces missing. What survives is enough to guide the next traveller, but rarely enough to recover every road that came before. Peary Race could not have known how many questions would gather round his surviving fragment. He could not have imagined satellites mapping Antarctic ice or sonar revealing drowned rivers beneath the North Sea. He was simply assembling the best world he could from the knowledge that reached him. 5 centuries later, the map still performs the same quiet function. It reminds us that the known world is always surrounded by what has been lost. And beneath the dark surface of modern seas, beyond the edges of surviving memory, older coastlines remain where they have rested for thousands of years, waiting without names beneath the moving water.